Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. Just real quick, I was just getting ready for stream. I don't really know why that song is still like kind of on the playlist of songs to play for, Leos Labs or Simuleos or whatever this stream is called now, because I just don't like that song. Like, it's the only one with a human voice in it. It's kind of weird. ZXML, Anu23, A Silent Tree. Hey, how are you guys doing? I hope you're all having a wonderful day. Right, so we're starting a little bit late today. We're going to end a little bit early today. Sorry about that. It's Tuesday. Every Tuesday I make tacos for my wife. And so it's just a tradition, Taco Tuesday. So I have to leave right at 6 so I can make tacos. And it's currently 3 o'clock p.m. I'm starting late because, this morning we had to do some healthcare stuff, and so I didn't really get back until like maybe 1:30ish, and then I had some stuff to take care of, just dealing with random internet strangers, and basically it took an hour. And so it wasn't until about 2:30 that I could start getting everything together for stream, so here we are. Still, a 3-hour stream is better than no stream at all, and honestly, it's longer than most of the other streams I used to do. It's probably still good. That way I can like limit the amount of stream time I have for just a little bit so that I can, maintain my stream stamina and stuff like that. Right. Unfortunately, I don't know if I'm going to have time to look at algorithm archive stuff today exactly. I want to, but I think what's going to happen is I'll probably work on the stuff I was working on yesterday, finish that up, and then if I have residual time from there, I'll work on the algorithm archive, probably around 5 o'clock p.m. Central European Standard Time. Is that the time zone I'm on now? Anyway, doesn't matter. Let's go ahead and get started talking about where we are, what we're up to, and what's going to happen today. And again, guys, if you have any comments, questions, concerns, ideas, anything like that, feel free to let me know, and I'll totally address it as soon as I see it in chat. Right, so we are building into a larger project, which is essentially a way for me to turn any image into a fractal. Now, this isn't particularly difficult. It's been done a lot before in a field known as fractal compression. Fractal compression is basically the act of turning any image into a set of analytical equations, which is inspired by iterative function systems, which create fractals. So that's why it's called fractal compression. So the whole becoming a fractal is essentially talking about that, the end goal of this project. However, we have a bunch of little, small mini goals to hit before that. And one big mini goal is the ability to implement a fast histogramming scheme. So most of you guys probably know what a histogram is. If you don't, essentially, let's draw a simple graph here. I guess I'm going to do it here. So this is a coordinate system. And let's say we have, a bunch of balls, right? So we have a bunch of green. Oh, let's try that one again. We have a bunch of green balls, a bunch of blue balls, and a bunch of red balls, or something like that. Right, where's red? All right, and we have a simple question, which is how many green, red, and blue balls do we have, right? So a histogram would say, okay, well, we have this many green balls, and this many blue balls, and this many red balls, or something like that. And that's all histogram is. Now, what you guys might be thinking is, this is an incredibly trivial problem to solve, isn't it? Yeah, it is. On the CPU, this is an incredibly trivial problem to solve. All you have to do is go through every one of these balls and basically say, hey, which bin does it go into? Bam, bam, bam. And that's why it's called binning. It's not hard. However, when you do this on the GPU, things get rather complicated rather quickly because you have to take into account the fact that we have thousands of cores all trying to do the same thing at the same time. And so they could be trying to write to the same location in memory. It's just a bunch of things that could go wrong. So in addition, this is essentially a search for all red, green, blue balls. Like, it's very similar to a search, which is a naturally iterative process, so it's kind of hard to parallelize to begin with. The point is, put it all together, it means that histogramming on the GPU is rather complicated. So yesterday, near the end of stream, we had just gone through a paper describing how to do the histogramming on the GPU. Now, there's a bunch of different ways to do it, but this one basically proposed two different ideas. The first of which, it was basically to have the parallelism happen on the GPU warp-wise. So here, if you guys don't know what a warp is, it is a set of 32 threads that act in parallel at the same time. So if you basically have a set of bins, so let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a set of numbers, whatever that set of numbers is, and you're asking how many 3s, how many 2s, how many 1s, etc. you have. Well, when you find a 3, you're going to want to put that 3, 1 second, into the 3 bin. And when you find a 2, you're going to want to put that into the 2 bin. And when you find a 1, you're going to want to put that into the 1 bin, so on and so forth. So essentially we're just saying, it's not super hard to do, but if we split this array in 2 and we have 2 cores going through it, then we might have the case where like 1, 2 wants to write here, or one person wants to write to this array element, and another person also wants to write to that array element at the same time. So what we're going to do is, because this wants to be done in parallel, we're going to allow all threads to write to this particular location in memory, and then we're going to tag that location in memory with the last thread that was successful. We're then going to stop that thread from doing any computation further, and then we're going to allow all leftover threads to write, which basically means that we've taken this process that was originally in parallel and we've serialized it based on how many conflicts we have. So everything's being done in parallel. I'm doing a pretty bad job of describing this, but we'll open up the paper in a second. Everything's in parallel except when you have 2 locations being written to at the same time, in which case that's done one by one. So it's mostly parallel, but there's some little, wriggles to it here and there. The only other thing to point out here is that even though we're reading this sequentially, 1, 2, 3, 4, 5, 6, 7, we're actually not writing sequentially, right? Because 3, this guy could go into any bin. Any of these numbers could go into any bin. So what we're going to want to do is we're going to want to put this into a shared memory resource to basically mitigate the damage of doing non-coalesced writes. That's the idea behind the histogramming method that we're going to be implementing today. Now, I'm going to be honest in saying that there are other histogramming methods that we could implement, and I'm actually remarkably interested in this thing. At the start of stream yesterday, I made a very bold claim saying that there is nothing interesting about the ocean. I said, there's nothing interesting about the ocean. That's what I said. I was very adamant about how I couldn't find a single interesting thing about the ocean, and I had absolutely no idea why anyone was interested in the field. I even went a step further. I didn't understand why people were interested in physics and chemistry, and biology. Right? I was like, I just don't understand why people are interested in this. I can't find a single thing that's interesting about this. And then I spend the whole day talking about how to create a histogram. And I'm like, wow, this is the most amazing thing ever. It's incredible. What I'm trying to say is I'm very biased here. I just thought it was really funny how at the start of stream, I was like, I really want to help this ocean conservation project, but I really can't think of anything interesting to do about the ocean. And then I just spend the whole day talking about histograms, and which is one of the most mundane possible things that you could talk about. But for me, it was quite interesting. And so I guess my point here is I'm actually incredibly interested in this. I don't think there's going to be a YouTube video about histogramming. Don't think there's going to be a YouTube video about the fastest fractal compression method like I was talking about before. I think we're going to leave all the videos until we finish the entire project, which might have 1 or 2 papers associated with it. But my point is, if I'm really into this, if I start getting even more into it than I already am, there may be a video about this. The reason I don't want to make a video is because we got to talk about a bunch of different things. We got to talk about GPUs. We have to talk about, parallelism. We need to talk about warps, memory coalescence. There's so many things that we need to talk about. Shared memory. It's just all this stuff. All of this we have to talk about in order for people to understand why this is actually interesting. And I just don't necessarily want to talk about that in a YouTube video because, quite frankly, it's quite complicated. Who's going to watch a video if all I'm talking about is GPU stuff? That's kind of where I'm at. I do love me some GBR LEDs. You are totally right. I got the number. You're right. Well, it's a cyclic permutation of RGB, so it's fine. Okay. I'm going to go ahead and have an image up here in the upper left, looking at the output of the fractal flame method that we're working on right now. So CD projects, flamify, and then we're just going to do mirage check.png, and we're just going to have this up here, again, just to have some sort of visual flair on screen. Maybe we go to this image. I actually like that one a little bit better. And then what we're going to do is pop open the paper and just start hacking away and getting this histogram method implemented. Again, I'm going to be totally honest here and saying I understand. If you're looking at the stream and you're like, I I don't understand why this person is interested in this at all. It seems super boring. Look, I get it. I 100% get it. What I wanted to say though was that, let me move this up. There we go. But what I wanted to say was, if this stream isn't interesting to you, just, let me know in the chat. Oh, hello. Just let me know in the chat. And maybe come back later when we do something a little bit more interesting. This project is going to take a few months of work. So we're going to be constantly working on it for at least the next few weeks. And then there's still going to be a lot to it from there. So don't think that, so just because you're like, I didn't like this one stream, doesn't mean that the next stream is going to be equally as boring, so to speak. We'll probably spend the next few days talking about histograms and stuff, which I find quite interesting, but I know other people probably don't, and then we'll move on to other things from there. Okay, so let's go ahead and open up the paper. CD projects, Simuleos, histograms, I believe. Now let's hear. Let me run zernal pp 10.1.zop. Okay, so this is the paper we were looking at yesterday. Move this over here, over there. Zoom in a little bit. Okay, and this is the primary kernel that we're going to want to write here. What is going on? Oh, never mind. Let me go up and just see. I think I wrote some notes at the very start here of what we need to do. So we need to talk about how we're going to parallelize across all entry values. We need to load the histograms into shared memory. This should be done based on the amount of memory in the system, blah, blah, blah. Okay. So essentially, we're just going to start hacking away, and we're going to see how poorly this goes for us. Okay, CD projects, Simuleos histograms. Over here, CD projects, Simuleos histograms. Okay, vi histograms.jl. So this is what I have so far. I'm using kernel abstractions. I have a very simple CPU kernel, which basically does the histogram for us. This is going to be used for testing, just to make sure everything's being done correctly. Then I have this @kernel function histogram tag kernel. I think it should just be kernel. And then down here we have the execution of this. So let me go ahead and create our test set and all this kind of stuff. So let me go up to the very top. One using test G, and we're gonna do. Is it @test set? What is it? It's @test set. I think this is what it is. Histogram tests begin end. I think this is what it is. Begin. All right. Let me get some more water, and then we're just gonna start working on it. Okay, so I think the first thing I'm gonna do is just create a random array. And then after creating the random array, just test to make sure that the histogram thing is working appropriately. So I guess we're going to launch it on the CPU first, and then we're going to launch it on the GPU after that. Just, again, as a simple test, just to make sure that the kernel is actually working correctly. So the first thing I'm going to do is, I think, I always forget the syntax for test sets, but it doesn't matter. We're going to say A is going to be our array, and it's going to be equal to rand from 1 to 10. For I equals 1 to 1,000, maybe. We're going to have to mess with it a little bit, but for now, it's okay. And then we're going to say histogram. We'll say final histogram. It's going to be equal to histogram values. A. Should work. Okay, so that's the final histogram we're going to test against. Now what we need to do is just call the kernel, which currently does nothing, but we're just going to call it anyway. And here's where I've forgotten all about kernel abstraction syntax. So cd backup directory, cd into GPU, L is here. Let me F5 over here. Oh no. Am I still live? Hello? Wait. My internet might have just gone out. So let me check something really quick. Okay. Wait. So why is my... One second. My side screen is not working. Give me 1 second. I don't know what happened. So I have a laptop on the side here that is specifically meant for... What is going on? Holy cow. Okay, wait. It's connecting now. What on earth? Okay, I don't know what just happened, but that's it's good to know. Hey guys, by the way, sorry for calling you out of chat. Okay, so what I'm going to do is I'm going to open up my vec add kernel abstractions thing, and we're just going to mimic that. I need to get better, and I need to remember how to do this without looking at this test, but I don't, so we're going to do it this way. Okay, so we have A, and so what I'm going to do is I actually have this thing called function histogram tag, which allows for me to run it. Does it do all of the... Wait a minute, I have to think here. So this is what I actually need to do is have an event here. Event is going to equal to this. And then what we want to do is wait on the event. There. So if I run histogram tag, the function, we're just getting started. We haven't even written the tagging part here. We're just kind of getting the infrastructure written. So when we do it, it should work. Okay, so in principle, I should have 2 runs here. I don't know how this is going to work. So I'm going to say CPU histogram. Well, CPU tag histogram. Wow, what a wonderful name here. It's going to be equal to histogram tag of A. And then we're going to try if has CUDA GPU, I believe is what I want. And then we're going to say GPU tag histogram going to be equal to histogram tag of the device version of A, which I need to copy over to the device. So we're going to say DA is going to be equal to Q array of A, and then we should just be able to run some tests. So we should be able to run some tests here. So I'm going to do a quick @test here. Can I name the test? It doesn't matter. Test. I don't think we need an isApprox. I think we can just do a directly equal to, but I will actually do isApprox just to be safe. isApprox. And what I'm looking for is CPU tag histogram, and then final histogram. All right, we're gonna grab the same test and move down here and change it to GPU. And that should be fine. Right here. Oh, cup of oats? Wait, what? Simula, wow, man, that's an emote. Yeah, wait, does he... Oh, with the sunglasses. I have sunglasses. If you want me to wear them on stream, it's totally fine. But yeah, that emote, that was an emote. Back when I would swim a lot during high school, my hair was just... I mean, it was always just completely dead. I mean, look, everyone's hair is dead, right? Like, it's just like protein sitting on the top of your scalp, right? But like, mine was especially dead. Like, it was so brittle and fragile. So like, every time I would like run my towel through it, it would just spike straight up, like exactly like that picture. And that's where the image came from. It's a really old image of me back from the high school swimming days. So. In principle, I think this should run. So let me just run it really quick just to see if it compiles. It's going to break, but it should at least run. So I'm going to do cd back into histograms. L is here, and now I'm going to run Julia. Actually, yeah, let's do include histograms.jl. Did I misspell kernel abstractions? I did. And also, I just realized I'm going to have to run Julia 1.6, which I have aliased to be a particular version of Julia I have installed on my system. Okay, there was one error. Let me check the error. Value not defined. Right, so where did I define this? This is going to be on line 18. Values. Try it one more time. Did I not write it? Wait, I clearly did something dumb here. Kernel not defined. Let's just keep going. Kernel not defined on line 33. It's because it's kernel exclamation mark. One more time. We should get two tests, 2 fails. That's what I'm looking for. Fail and error. The other one's an error. Has CUDA GPU is not defined. I think that's because I didn't do using CUDA at the start. 1. And then using CUDA. Try it one more time. And what I'm looking for are 2 fails. That's what I want here. 2 failed functions. Doesn't look like I'm going to get those. Give it a second to do the compilation. And then once this is all done, that means that we have like a test bed for the kernels that we're going to write, which is fine. You know, that's kind of where you need to start. So it says on line 37, which is obviously the start of the test set, and it's going to be on line 31 here. So we do CUDA device not defined. What is it called? I thought it was a CUDA device. Control D, go back a directory into GPU, and then go into vec, add kernel abstractions, .jl, move down here. It is a CUDA device. It is 256, which is the number of threads. Is it maybe because I didn't have CUDA kernels? Oh, hello, let's try that one again. All right, there we go. Quit here, open up Julia again, try including it, see what happens. And then if this runs, again, we have a test bed. Add CUDA kernels. And once all that's done, we can then start writing the actual kernel, which is going to be a pain. It's going to be a huge pain. Specifically because I actually don't know how to run kernel abstractions. Like, I don't know how to use shared memory appropriately with kernel abstractions. That's going to be one issue. Include histograms.jl. Again, we're looking for 2 errors in the tests. And once we have that, just come on, give me something. Line 45. Test is a prox. Yeah, that one's supposed to fail. Macro expansion. Give it a second to do the pre-compilation, and then we should be good to go. Okay, I had another error. What do we have? Is on line 35. What's the issue? Oh, this is a messy issue, isn't it? Oh, line 38. That doesn't help. That's the test set. GPU compilation of kernel. Passing and using non-bits type argument. Okay. Well, what does that mean? Non-bits type argument means... Oh, why? I keep losing internet. What is going on? My Wi-Fi is just not having it. But I think the stream is still up. Yeah, so it must just be the Wi-Fi that's kind of going down. Sorry about that, guys. It's not an issue for you guys. No, I don't think anyone on stream is noticing it. But my Wi-Fi is going up and down. I mean, I'm connected via Ethernet now, so it's not an issue for me for streaming. It's just disconcerting when I look over to my side screen and then all of a sudden it's just not there, you know? I check it fairly regularly just to make sure, you know, that I didn't miss some chat or something because it got spam blocked or something. Okay, so we're going to figure out why this is breaking, and it is because GPU compilation argument 5 of your kernel function is of type vector int64, which is not is bits. Cool. All right, so let me explain why that's kind of an issue here. we don't have that. Kernel. Oh, kernel takes in 2 things: histogram and values, and then it does ND range of size of histogram. Argument 5, we don't have a 5th argument, is of type vector int64, which is not is bits. Also, why is vector int64? Oh, is it because... Right. Okay, I understand now. It's because it's not a coup array. So we're going to do the histogram is equal to that, and then I suppose I need to dispatch this depending on whether it has a CUDA GPU or not. I don't really like that, but that's okay. So the next thing I'm going to do is if has CUDA GPU, and here, ooh, that was supposed to be the word end. It did not turn into that. And here, let's do yank to yank, paste it up here. And then what I'm going to do is Kure here. For values, and then hopefully this will run. Dang, I thought that's what it was. Okay, let's keep going. What else could the error be? Argument 5. Well, okay, I know that's going to be an issue, so let's just go ahead and run that. Histogram. Oh, that's because values are already a Kure. Histogram is the one that's not the Kure. Yeah. Okay, let me see what we have here. I think this is a different error, although I'm not quite sure. Let me clear the terminal. Oh man, I'm sorry. Give me a second, guys. So what's the error this time? It is argument 5 of your kernel function is not type vector int64, which is of type vector int64, which is not isbits. Okay, what is a vector int64? What is argument 5 of my kernel? So if it has a CUDA GPU, we're running this event. Otherwise, we're going to run that event. Sure, I should probably just put that in an else statement just to make sure we don't accidentally call it. Okay, see what that does. Okay, now we have 2 failed. Oh, I see what happened. Okay, obviously, because it wasn't in an else block or whatever, it just called it anyway. Okay, good. So we have 2 failed tests, which is what I wanted to see. There's one other thing I have to do here at the end, which is modify this test here so the GPU is actually moved to the array. So array moved to the CPU before doing this test. Do that, right. One more time. We should still get 2 failed tests, and that should be fine. Okay, so this is a general infrastructure. I'm going to commit this. Git add histogram.jl, git commit -m, adding infrastructure, well, skeleton code 2, test histogramming method. Sure. Git push origin master. Every single time. Well, if there's one thing you can count on is my inability to type. Yeah, so I don't know how relevant this is, but I've been realizing that a lot of people on the internet are very bad at communicating with other people on the internet. I know that's a very common thing, but just so the other day, someone sent me a message saying that one of the chapters in the algorithm archive was wrong. And they're actually right, for the record. They're completely right. It was the forward Euler method. It does need to be updated. The graphs in and of themselves are not wrong. They're just really misleading. The text is wrong, and there was a notational error in one of the formulas. Easy enough. But the thing was, like, it's such a... I don't mind being corrected, right? But the thing is, there's like 2 different ways you can correct someone, you know? Like, one is to be like, hey, I think there's an error in your stuff. Here's what I think the error is. And I'm like, great, okay. It's even better if they say, here's what I think the error is, and here's how I think you can fix it. But this guy was like, you're completely wrong here. Like, everything about this chapter is completely wrong because of this weird notational error you had at the start. I'm like, okay, well, to be fair, I don't know how that notational error got into the algorithm archive, but it's easy enough to fix. It's just like a 1-letter change. And then he was like, oh, your graphs are also wrong. I was like, yeah, okay. I know why the graphs are wrong. I know how to fix it, but also it's just a small change. It's not so much to fix. But man, it was like the end of the world. It was like, man, it just constantly, like, I don't know. It's just the way in which it was discussed was very weird to me. It felt like, they kept saying like, I'm only going to talk to you if you're willing to listen. And I'm like, you're making it sound like you're some sort of like elder sage passing down knowledge to like, little me who has no idea what I'm doing. And I'm just like going out into the wild for my first time completely. You know what I mean? Like it was such a weird thing. And I just feel like, if you're one of those people who are going to be providing feedback to other people, just like, acknowledge that the other people probably also know what's happening. And don't come from a place of arrogance about it, Like, I don't mind, I genuinely don't mind being wrong. Like, all the time, I'm wrong. Constantly wrong. It's just that there was something about the way that this guy was correcting me that was really just rubbing me the wrong way. It would have been fine if they would have said, hey, I think your graphs are wrong because of this reason, and I think, there was a notational error. I would have been like, great, yeah. but it was like a huge, like super long conversation about something that was ultimately like pointless. And I'm like, come on, like it's a simple fix. But I kind of out of spite, I haven't fixed it yet because I just didn't like the conversation I had. I'm sorry. I don't mean to call this person out. I mean, you guys don't know who I'm talking about, but it was such a weird conversation. I don't know how to talk about it without like spoiling anything or like accidentally unveiling who this person is. They're not like a core member of the community. When they contacted me, they used my name in quotes. They're like, yeah, I'm looking for someone in charge of the algorithm archive. He goes by the name of Dr. James Schloss in quotes. I'm like, that's my name. What? Why are you putting it in quotes? Are you just like, claiming that I don't have a PhD? Is that what you're trying to claim here? Like, I don't understand what you're doing. Like, it's one thing to be like, you got a problem. It's another thing to be like, yeah, I don't think you actually have a PhD, and I'm going to insinuate that with air quotes or with quotes in my writing. I don't know. It's such a weird thing. Anyway, histograms. Let's just keep going. I'm sorry. I don't know why I brought that up. I really shouldn't have. I shouldn't rant about that kind of stuff. Okay, so how am I going to do this? Well, in the case that we have, shared memory, I don't know how that works, actually. I want to do some shared memory tests with the CPU and GPU. Why were they so hostile? I don't know. I get actually a lot of feedback from several people. And sometimes it's quite nice. Like, actually, a lot of the feedback is positive, right? Like, when you put stuff out there, people generally like what you put out. But then there's always like 10% of people who say very negative things. And it's just, again, I don't mind the negativity. I think the negativity is actually worth it in some cases. It's just, there's a way to give feedback and there's a way not to give feedback. And like, the way not to give feedback is to use my name in quotes. Like, I'm like, that's not actually who I am. And to be like, I don't know. It's such a weird thing. Like, I get it. The forward Euler method was like one of the very first methods I put in the algorithm archive like 5 years ago. It was definitely in heavy need of revision, no doubt. And I'm going to do that in the next few months when we start talking about the Barnes-Hut algorithm, doing some galaxy simulations, yada yada. But it was just a weird thing. I don't know. Yeah, like, I was talking to Grant about this the other day. When you make content online, you get a lot of feedback. Most of it is going to be positive, but there's always going to be like the 1 or 2% or 3% or 10% of people who say negative things. And, you just have to figure out how to filter whether that negative stuff is actually worth listening to or not. And a lot of times it is worth listening to. It's just that it's hard to get through all the emotional just walls that people build up. Yeah, I mean, a lot of the negativity that comes to my channel is actually specifically because people are like, they watch a video of mine and they're like, that's not a 3 blue 1 brown video. So my gosh, I consistently am losing Wi-Fi connection on my laptop. It's absolutely insane. I have not had Wi-Fi at all on my laptop. Anyway, the point is, like, a lot of people will watch a video of mine and they'll be like, 3 blue 1 brown did this better. I'm like, 3 blue 1 brown never made a video anything like this video. What do you mean 3 blue 1 brown did this better? This type of stuff. Anyway, let's ignore that. What I need to do now is kind of do a shared memory test with the kernel, and see how that actually works on the CPU and stuff. So, how do we use shared memory with kernel abstractions? That's my question. Because it's been a long time and I don't remember. Let's go here, and I'm going to look up. Probably docs should have something about shmem. Docs stable, sure. And let's go to shared memory. Okay. Right. Okay. Shared memory. Right. All right. This might be a bit more complicated than I thought. At index, at local mem, at synchronize, at private. Right. So I believe this is where things get complicated. I don't actually know what they call shared memory in kernel abstractions. It's been a long time and I don't remember any of this. Naive transpose, we don't need to use matmul. None of these are going to be using shared memory. API, kernel language, sure. Const index local mem private. This is what I need. So is it going to be at local mem? Local mem declares storage as local to a work group. So a work group, this is what it is, local mem. So I need an example of using local mem on the GPU. Perfect. So how about, I mean, I could do a simple like transpose or something like that. Like I could just write up a naive operation that uses shared memory. I could do something like that. Or let's just use the histogramming. Let's try to figure this out on the fly. So local mem t and then dimensions. Is this done? How do we launch a kernel with local mem? This is of course all the documentation they give, which is not great. Okay, so what do we do? Crap. They obviously don't have any more information than this. Okay, let's just see what error we get. So we're gonna run local mem of type t. How do we know how much we can actually read in? I don't know, but so we're gonna do at local mem. Then we need a type, which is gonna be of type, is it of type vector? int64? Is that what we need? Maybe? Maybe. I actually have no idea. Almost Toaster, thank you so much for following. Really appreciate it. Local mem of type t, and then of dimensions. So do I need int64 or int32? Probably is what I want. And then we want dimensions of like, I don't know, but maybe 1010. Just to see if this runs. Let's go here, include. This is probably going to break. I think it's going to fail outside of tests. Oh, maybe it worked. Okay, here's what I'm going to do. I'm going to go to my old code base and I'm going to look at some of the kernels there and see how this works. So let's go to github.com, and let's take a look and see what the code looks like. So we're going to go to Klima. Sure. And then we're going to go to Klima here. Oh, sorry, Climate Machine. And let's go to source, and let's go to kernels. Oh, it's been so long. Numerics, probably. System solvers, mesh, DG methods, DG model, DG methods.jl. There should be some kernels in here. Kernel abstractions. Let me look for. Nope. Gosh, I don't remember any of this. I just want to look at some example code. DG methods, DG model kernels. That's what I was looking for. Perfect. Okay, let's see what we got here. Right. So we do balance law, blah, 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 at uniform begin. That's all fine. I'm looking for local mem. Here it is. FT is a floating point type, which is fine. And is of dimensions 2. Okay, this is a 4-dimensional object. Perfect. Okay, that's what I needed. So now all I needed to figure out is how we call this. So what I need to do is figure out where we call volume tendency, which I don't remember. Or not where we call it, but where we configure it for calling. But I think ultimately we're going to be fine. The next thing is to ask how much shared memory we actually have. For right now I'm using a GTX 970, which is not a good graphics card, but it's what I've got. Off topic, GPU shared memory, Grand Theft Auto. Also shared memory where is available 1 megabytes. Okay, so I seem to be able to fit a rather large amount into shared memory, I think. I don't remember. Let's just kind of mess around a bit. Okay. So we have the local mem int32 here. Let me make sure I've defined everything as ints. Int32. I mean, okay, let's just do... should it be 64-bit or 32-bit? I mean, the algorithm kind of says it's 32-bit, but it doesn't really matter. I mean, we can do 64-bit as well. I think we're kind of bike shedding here. Let me go ahead and I'm going to keep it as int32 for now, but we might change that later. Okay, so the first thing we need to do is load bits of the histogram into shared memory. This is a bit complicated. I'm not exactly sure how to do this. So what we'll do is we'll assume that all of the histogram can fit into shared memory. So let's go ahead and do that right now. So if all of the histogram can fit into shared memory, I'm going to comment that as well. This is for a one-dimensional histogram for 2D histograms. Or rather, binning, I guess. We need to think about dimensionality. We'll say n-dimensional binning, which is what we actually want to go to. For n-dimensional binning, we need to think a bit more. Although for n-dimensional binning, it can actually go back down to one-dimensional binning, so I don't think it's actually that big of a deal. So in 32, and what we're looking for is the length. I guess I'm looking for the following. Length of histogram. And then do I have to put a comma here? Let's just see what that does. Is that going to work? I think it failed outside of test that time, didn't? No. I think that's fine. Maybe not, but we'll see. Okay, so now we've basically allocated the entire array to be of that size. So how do we actually use local memory? That's the next question. So let's take a look here for local mem. I'm in the wrong directory. DG methods. Here it is, local mem. Okay. So we're gonna look for shared flux. Okay. Shared flux, IJS. So we just use it like any other array then. Perfect. In that case, we might be able to just pull out the histogram method that we have up here. So the next thing I'm going to do is kind of define our thread indices and stuff like that. This I think can be done just by TID is going to be equal to, what is it, at index global. This is where I get a bit confused. Is it n tuple? And then what we want to do is, do we want a TID x and a TID y? I mean, it's only one dimensional right now, so this is probably fine. Although does it have to be two dimensional? Let me take a look at the matmul kernel and kernel abstractions. Where are we? Let's just go over to 5 and do, what am I doing? GitHub.com. And let's go to kernel abstractions. Perfect. And now we're going to do test. No. H. We're going to do examples. And then we're going to do matmul. Okay. In this case, we have IJ's at index global n tuple. Right. Because matmul is also a two-dimensional thing. Let's look for anything one-dimensional. What? Okay. Let's take a look at the documentation then. And let's look for at index. Indexing at index macro. Take global, linear produces an N64 that can be used linearly to index memory. That's what I want. Perfect. So we have a thread index. Now what we have to do is kind of start implementing the histogram kernel that we have. And I think as long as the entire histogram can fit on shared memory, which isn't necessarily clear, I think this is actually what we want. And then the last thing we need to do is copy our local memory guy back onto the histogram at the end. Do I just need to do histogram? Wait. I need to think about this again. I'm so sorry. So when we define shared flux up here, do we read shared flux in? We do not. So we say shared flux is going to be equal to that. Sure. Okay. So I guess we're going to say shared histogram is going to equal to this. Then the next thing I need to do, we have everything on shared memory, so we have to copy it back out of shared memory. So probably what I want to do is synchronize or something once once the while loop and everything is done, and then copy out. Yeah, that's probably what I want to do. So what I probably want to do next, okay, let's think about it one step at a time. So in here, what I'm going to do is probably just implement the kernel as we see over here in this paper. Okay, well, let's do it naively first. Okay, so here we're indexing through all of the values that are going in. Let's go here, GPU tag histogram, and I want to make sure the ND range is going through the number of values. Okay, and then down here we're just going to say values, shared histogram of TID, values of TID is going to be plus equals 1. So we're just bumping it up every time we can. Again, this doesn't necessarily take into account when we have like conflicts across a warp, but we'll deal with that just in a second. And then the next thing I need to do is copy it out of shared memory. So then I would just want to say something like histogram is going to be equal to shared histogram. But actually, I'm not sure how to do that right now. Do we need to do a like a CUDA device synchronize or something? Let me think about that. What kind of fractal are you? Not really sure. So we're gonna do the fractalify. So basically, we're gonna do that in essentially a few weeks. We have a lot of building up to do from there. For those of you who might be wondering, like, what we're doing, why it's called becoming a fractal, all this kind of stuff. The reasoning here is that, we can create like really interesting patterns like this one over here with something known as the fractal flame algorithm, right? So what we're trying to do is we're trying to, one, speed up the fractal flame algorithm so we can get these images out faster. And then two, what we want to do is basically take any image and turn it into a fractal flame. Now, the fractal flame method works by creating a series of equations that are then turned into, this pattern that we see up here in the upper left-hand corner. So, essentially what we're trying to do is take any image and turn it into a set of equations that can then be turned into a fractal that looks identical to the image. Does that make sense? So we're just going to be manipulating the equations, doing some sort of genetic algorithm or machine learning pattern, maybe reinforcement learning is what I'll go for, to make it so, we modulate the affine transformations in the equations that we have to recreate the image. That's kind of what we're looking at right now. So we want to take an image, create a set of equations that closely approximates the image. Sorry, let me rephrase that. Take the image and then create a set of equations that, when put through the fractal flame method, closely approximates the image that we had to begin with. That's what we're looking for. So right now we're at the stage where we're just trying to speed up this algorithm, because right now to create an image like this, it takes 6 minutes or something like that, which is way too long, especially considering, like, if we zoom in, it's quite grainy, right? So we want to speed that up a lot. To be fair, the image that takes 6 minutes is actually this one in here, which is a little bit nicer. It's a little bit less grainy, but there's still a lot we want to do here. So that's kind of where we're at here. Hey Henry, how are you? We're becoming a fractal by becoming a fractal by becoming a fractal. It takes time. It takes a lot of time, Also, for anyone who might be new here, I do want to point something out. The point of Laos Labs is to do research in an open, clear, open and clear way, right? It's to make it so anybody who wants to, approach this research for the first time, anyone who wants to, understand the publications and stuff that we're putting out as, independent researchers and stuff, that's kind of the point of this channel. So, yeah, that's where we're at here. You know what? What were the inputs made for those images? So right now, these, there were no inputs for these images. It was a series of functions that were kind of blended together. So one was a heart, as you can see here. The other was kind of this swirl that kind of did a 90-degree tilt, which is why you see another heart in here. And then the last one was kind of like a sine function, or something else, I don't remember. But it was a combination of 3 different fractals kind of put together. So that's what created this one. This one, I think, was the heart function with the swirl and then an additional sinusoidal oscillation on top of it, which made it so we have like this, low density, high density, low density type of wave going on. It might have been sine squared or something. There, perfect. What were those inputs made to? That UI is MDOS 1988. What is MDOS 1988? Is that Microsoft Windows? MDOS 1988. Images. Oh, I have no idea. I don't know. Microsoft DOS, I'm pretty sure. Microsoft DOS 1988. Let's take a look at this in Google, maybe. I've actually never seen this before. Images. Well, okay. It's so what it actually is OpenBox. If you're interested in the theme, I can give it to you. It's over here on Discord. Just go to off topic. Here, I'll go ahead and give you guys a link. Copy, paste. It's over here on the off topic channel. Go to the pinned messages, and it's right here. So it's like the second pinned message. There might be others that are also pinned, and I'm not entirely sure why they're pinned, but you know, what is this one? Oh, sugoi. Sugoi. That's actually quite cool. I didn't remember it, but I'm glad it's pinned. Anyway, so that's how it is. Yeah, I use light mode for most things except for terminals. So, wait, monster. Wait a minute. I've been flashbanged? I'm sorry. I like light mode. I think light mode makes things easier to read for the most part, with the exception of like programming things and stuff like that. So anything that you're not looking at for a long period of time, light mode is just easier to read. And like, look, I know I'm going to get flack for saying that, but I think it's true, right? Hey, Emrys, how are you? I'm going to say one more thing while we're on a rant here. Let me go to actually my Twitter. And let me go to profile. And then we're going to pop down here to... Where is it? Oh man, I've posted a lot of stuff. That's what I'm looking for. Right, so like I said before, the point of Laos Labs is to kind of do research in a way that's like available for as many people as possible. I was hoping we could kind of get some form of momentum towards having a research tag on Twitch, so that we can kind of filter by people who are doing like, you know, novel academic research, like things that could be published, right? Like that's what I'm hoping for. There aren't very many people at all on Twitch who are currently doing that. In fact, I can only think of like one or two other people who are doing that. So I would love to see more people on Twitch who are doing research. Not necessarily like the research I'm doing. I mean, like maybe chemistry, physics, something like that, but just stuff that's not like game development or software development. It's specifically meant just for education and meant for, not education, but meant for research. It's meant just to push the boundary of human knowledge just a little bit. What do we have here? I'm good, but I'm procrastinating, especially for writing. You're talking about light mode. Get rid of that light theme. It's attracting the bugs. Well, okay, there is that. That's fair. You know, light theme does attract more bugs than dark theme. I'll probably accept that argument. But like also like, why do you have so many bugs around you? Like, are you like outside? Is that are you doing all your computing like out in the open air? I mean, that's fine, but it's kind of a bit weird. Weird how they have a science and tech section, but no tags. Right, so there are tags, like there's a programming tag, and there's a Linux tag as well. I'm under the Linux tag. Oh, maybe that's why I get so many comments about my distribution and Windows Manager and stuff like that. Maybe that's why, because I'm also streaming under the Linux tag. That would make sense. Anyway, point is, there are tags, but it's just, right now the science and tech category is largely filled with, like, I don't know, people who are streaming about ducks and stuff. Like, it's like almost farming content, which is not exactly what I'm looking for, you know? Like, when I go to science and tech, I'm looking for people who are doing research. That's what I want. I'm in a bush. Okay, that's fair. Like, if you're in a bush, fine, use dark mode. Like, that's my recommendation. If you're in a bush, use dark mode. When I have some time, I'll definitely want to jump in with streaming open research. Yeah, I'd love to see that. Can we make a collab on the hub? What does that mean? A collab, a collaboration on GitHub, but are you talking about a collab as in like a lab with multiple people? We do have the algorithm archivists, which is where I put all of the stuff that I'm currently working on. So if you go there, algorithm archivists, here, give me a second, I'll get there. Nope, this one, and then go to the algorithm archivists here, and then go to Laos Labs here, and there. So these are all the projects I'm currently working on. I'll just kind of paste them in here. Hey, Trash Talk, how are you? Okay. Cool. Okay, so now the last thing I need to figure out how to do is get this histogram off of shared memory and put it onto this histogram that I've read in. Not entirely sure how to do that. The hub? The hub must be GitHub, right? Like, I'm not wrong, right? It has to be GitHub. Anyway, How am I going to do this? Because we're not iterating through the shared histogram. If you're not doing astronomy, don't even use dark mode. Use night mode, basically red mode. Wait. What? What's... I didn't know? Is there... What is night mode? Oh, night mode is just like a red tint, right? Pizza Hub? Pizza Hub? There's no such thing as Pizza Hub, right? Oh, I mean, maybe there is. I misspelled it, but I'm sure. Like, let's see. Let me see if I can find a Pizza Hub. All right, if they accept Git commits, you know, maybe we're in business. Pizza Hub, Pizza Hut, Pizza Hub, Pizza Hub. All right, learn more. Pizza Hub COVID-19 response. We've shut down. It's Pizza Hut. No, it's okay. We found out about Pizza Hub. It's fine. Okay, so we're good to go. Don't worry about it. If you want, we can start a collab at Pizza Hub. Okay, so right. The reason I'm struggling with this is because I don't actually know how we're iterating through the array in shared memory. So what I'm going to try to do is go to this paper and see if they have source code available, and see what I can do. So I'm going to go ahead and close this for now. I'm going to reopen it in Ocular. Ocular 10 point something. Oh, sorry for the yawn. Control F, code. Code. The source code, that's what I want. Here we go. Open this up. And let me just see what they're doing in CUDA for the shared mem and stuff. Before I leave, so you know, thanks for letting us know that. I appreciate that. That's exactly what I wanted to know. Your requested page could not be found or is no longer available. Great. Okay. Let me just double check. I didn't have a typo. Oh, there is a typo. Okay, that's fair. This, that, R. Oh, come on. Come on, please. All right, let me try it one more time. How am I gonna do this? Let me try opening it up in another browser. Change this to be tilde. Oh, come on, stop it. Tilde R. Come on, please. I mean, I don't have much hope here, honestly. I don't have any hope at all. Okay, that's what I thought. So, where might I find the code if it's no longer available? The Wayback Machine? So for the record, if anybody's wondering, this is why you have Zenodo links. HTTP, let's just kind of copy whatever this was here. Copy text. Paste text. Browse history. Is this gonna work? No. Ah, no. I was excited. I was excited for just a second. So, okay, let's talk a little bit about replicability in science. If your paper relies on code, generally try to make that code at least somewhat citable. Although, admittedly, this paper was probably written before that was a thing. Like, when was this paper written? Way back in... I don't know. It doesn't have a date. There's no date. There's no date at all, is there? Okay, let's look it up on Google Scholar really quick. See if I can find a date associated with this. But nowadays, if you are publishing a paper and I don't know, if you're publishing a paper and it relies on software, just be sure you get a link to that software that's available for longer than, just a random website, right? So to do this, you can get something known as a Zenodo link. Zenodo, software, citations. But another way to do it would be to put it through the Journal of Open Source Software. Also, there are ways to do this natively in GitHub nowadays as well. Okay, what was I going to do? I was going to go to Scholar, and I was going to look for this guy. I just wanted to see if I could find... so it was published in 2007, which is, 14 years ago? Crazy, that's 14 years ago. What was I doing? 14 years ago, I was installing Linux for the first time. That's what I was doing 14 years ago. It was a big, momentous occasion that happened in my life. Gosh. Okay. Long time ago. I mean, what were you guys doing 14 years ago? I mean, I was like in the middle of high school, right? Like that's what I was doing. No. Where was I? 2007 was the year no. That was like freshman year in high school for me. Okay, so there is no source code available here. I think we could look at a forward citation and find some source code for the forward citation, which would be fine. But I think we can get away with figuring this out. So let's just kind of mess around a bit. Okay, my main problem here is I don't have an index to go through. Oh, you found it. There we go. Thank you. See, this is why I have chat. There's always someone that can find stuff that I can't. Okay, wonderful. So, 14 years ago, I was 9, so I don't remember exactly. 14 years ago, I was playing World of Warcraft 16 hours a day in my room. Oh boy. I think the URL got misencoded. That's totally fair. Man, like, there was... You know, one thing that World of Warcraft, I think, taught my generation, Guild Wars as well, taught me this, is actually work ethic. I know a lot of people say that, you know, people wasted their life playing World of Warcraft, they wasted their life playing Guild Wars, whatever it is, but like honestly, you had to work hard for those titles, man. You had to really, really grind. And getting that mindset of just working really hard to get something that's kind of meaningless at the end, I mean, like, that was drilled into us with MMO ideology or whatever, right? So, I don't know, I kind of feel like, I don't know, download source code. Okay, kudahist.zip. Let's see what this does. All right, so we're going to, what am I going to do? I'm going to cp downloads, kudahist.zip here, and we're going to unzip that. Thank you so much for this, by the way. Okay, examples. Perfect. CD examples. All right. CD Kuda? kudabasics.h. Oh, CU. Oh no. DOS to Unix, everything. Star. Okay, what do we have here? Copyright. Oh, it's copyright. Am I allowed to show that if it's copyright? I guess so. Relevant publications, efficient histogram algorithms. Okay, what is this guy? Includes if MATLAB. Oh no. Oh no. Give me a second. I need to just... Whew. Okay. Okay, existential crisis over. Okay, let's try to get through this code, see what's happening. I'm gonna just full screen this guy, I'll make it huge, and we're just gonna kind of browse through it, see what we can figure out. I'll just make it, I don't know, something like this. Oh, geez, it just doesn't bode well, does it, when you see if and def MATLAB at the start of a file? Holy cow. Like, look, I mean, obviously this is written in a different era, but like, okay, let's do it. Okay, so they have CUDA malloc wrapper. Okay, look, I'm only looking for the kernels, which in 2007, were you allowed to have the kernels? You might have actually had to have all the kernels in a separate file. So let's go to ls here. Is there a kernels, GPU basics, GPU hist.cu, vi GPU hist .cu. Okay, relevant publications, all this type of stuff. GPU basics, GPU reduce histogram. Okay, this is kind of what I'm looking for. Global void. Just like, yeah, it's fine not to stick to the 80 column rule, but what kind of column rule is this? Like, you're not even trying. Okay, external shared float. So this is their definition of the shared block. They have TID and BID and int threads is totally fine. So what are they doing here? They're going to do shared is, yeah, so here's our plus equals 1, which I had before. Then they do async threads. And then they do, okay, so this is a question that I had. How do they, right, so the issue I have is that you're indexing over the values, right? You're not indexing over the shared memory. So how do you grab something from shared memory and put it back afterwards? Yeah, I don't know. So that's what I'm trying to figure out. Maybe you just have a certain number of threads. All right, let's do this in a dumb way. We're going to say the following. If TID is less than, just hear me, this isn't the way I'm going to do it, but I'm going to say this will work. If TID is less than, histogram, I think less than or equal is what I want. And I want length of histogram. And then end, we're going to say histogram of TID is going to be equal to shared histogram of TID. Okay, again, this isn't the best way to do it. It's just, this will probably work. It's not going to break, is what I'm saying. Okay, so, oof. So they have a sync threads in here as well. So what's going on here? We have, allocated by the caller must be set to the number of threads. Okay. Then we have const unsigned int TID. We have int GOFS is imul. What is imul? Am I dumb? Don't answer that. I know the answer. The answer is yes. But I don't fully understand. Okay. Imul. What is imul? IMUL. I should know that. Oh, just get away from me. Cancel. Close. IMUL C++. It might not be. Oh, don't give me that now. When the one operand form of imul is passed a 32-bit argument, it effectively means EAX times source, where both EAX and the source operand are 32-bit registers or memory. Okay, so this is an integer multiplication of BID and cell length, where BID is the block ID and cell length is being read in, probably as like how big you're splitting, probably is what we're looking at here. Okay, so now we're saying for int I is equal to TID. What? What is this? Is this a reduce? For int I is equal to TID, I is less than cell length, I plus equals the number of threads. This is, okay. Yeah, that's fair. I understand why this has to happen. Because what you've got to do, if your histogram is larger than the amount that can fit on shared memory, you can only fit so much in shared memory. So what you're going to have to do is split the array up. And so this is iterating through the split arrays on shared memory, I think is what's happening here. Interim. What is interim? Interim is being read in as float interim. Perfect. From global memory. Love the naming of old C code. we're getting there. Okay, so now what is this? If and def device emulation. For unsigned int D is equal to threads. Oh no, bit shifted by 1. Right. D is greater than 0. D is bit shifted by 1 each iteration. See, here's the thing, guys. As much as I like to pretend that I understand, and I know what I'm doing, sometimes I run across, coding projects that are beyond my comprehension. This one is slightly at that level where it's going to take me a second to understand what's happening. This one, I think, is comprehensible. I don't think I'm going to have trouble understanding what's happening here, but I think it will take me a second to do that. Usually, what I used to do when I ran into code bits like this is I would quit stream and I would try to figure it out on my own. But This is Leo's Labs. It's a new day. I'm going to try to figure this out on stream. We're going to see what happens. First of all, what I'm going to do is run our Julia code to make sure the Julia code is running. I think this is valid Julia code that should work most of the time. I think. I don't know. This is some really low level stuff. Right. It's stuff that I should know but don't. And this is also why I'm like 50-50 on whether we should actually make a YouTube video on this or not. Because there's gonna be a lot of things that I need to do to kind of like speed this up. Like for example, using, static vectors and stuff in Julia, which I honestly don't know so much about, on the CPU side. There's just a lot of little things that I have to figure out that I don't know right now. Oh, also I need to make sure I have, what is it? I mean, it's a low-level language. Well, right. But yeah, I was echoing that a bit. Let me go over here. There's @index, oh crap, what is it? It's something @index, @inbounds. That's what I'm looking for, @inbounds. Anytime we do an operation, we want to make sure we're doing @inbounds. Like for example, this one. There, and probably here as well. Okay, so the reason we want to do that is because we want to make sure that the bounds checking is not being done by anyone other than us. So @inbounds tells the compiler that, this operation will be in bounds. Otherwise, feel free to segfault the code. We don't care. Segfault it, it's our fault. That's what the @inbounds tag does. Okay. I could have wrapped everything in an @inbounds, but we'll deal with that in a second. Okay, so my next question is the following. Can I just run this? What happens? What happens if I just run this, right? Yeah, what happens? What's the worst that could happen, right? So let's go ahead and run include. Something's gonna break. We might get a segfault. I don't know. This is an iteration, a bad iteration, but an iteration of the code that we'll eventually write. There's gonna be a lot left to do, but if this runs, I will commit it and say, look, we made a step. It's a small step for man. I'm not gonna make a joke about that. I'm above those types of jokes. Like, we're not gonna talk about that. That was not even a good joke. I was just like, what was I even gonna say there? Where's my water? It's doing something. I don't know what it's doing. I mean, maybe we ran into a, yeah, I don't know what it's doing. But it sure is doing something. So we'll sit here and wait just a little bit. It's compiling something. I don't know what it's compiling. Performing scalar index. Aha. So it's doing a scalar task somehow. How? What line? So what I'm going to do is the following. I'm going to say if it has a CUDA GPU, we're going to run this test. And also I'm going to say CUDA.allow scalar equals false in here. I think that's CUDA.allow scalar false, I believe. Okay, so we had an error, which is perfect. Wait a minute. Why are we still doing scalar operations? All right, let's try it one more time. Okay, where is the error? It is still doing performing scalar indexing on task runnable. Invocation of set index resulted in scalar index of a GPU array. Why though? This is typically caused by calling an iterating implement of a method, such method implementations do not execute on the GPU, but very slowly on the CPU. What? Oh, is it the... What? Surely it's not in this, is it? Wait, what's... No. We define the zeros and we pass them on to the coup array. Okay, so what's doing the iterating? What is our scalar operation here? Let's look at line 60, which is there. Is a prox. Ooh, what? Oh, okay, that's obviously failing. Right. Allow scalar not defined. Okay, right. That is because I'm dumb. Okay, so let's go into VI back into GPU, and we're going to do vec add kernel abstractions.jl CUDA.allow scalar no underscore. I swear there was an underscore there at some point. Okay, quit here. We're going to include it one more time. And now what's the issue here? The issue, invocation of set index. It's still giving us an error for some reason. And it's just saying both of them failed. But where's the scalar operation? What scalar operation are we running here? Okay, so let me try modifying the kernel again. And just removing all the kernel contents and just doing something dumb here, like something really dumb. We're just gonna yeah, here's what I'm gonna do. I'm gonna comment all of this out. DD, just screw it. It's all being commented out. So we're gonna comment that out and comment this out. And let me see what part of this operation is creating a scalar operation. Include, no scalar operation. Okay, so now we're gonna do TID. Oh, I should have left it down there as well. DDP, perfect. Okay, try it again, include. Still obviously not scalar. Okay, shared histogram. Why am I doing this? Yank, paste up here. This obviously should not, there's no scalar in there, obviously. At inbounds, yank, paste down here. Still no scalar. So it's this one. Okay, perfect. We have an error. Scalar indexing disallowed. So what? It's a problem. Histogram is a. How is this a scalar index? Am I dumb? What's going on? So this line, it doesn't like this line. So if I run this again, we should get scalar indexing disallowed again. Yeah. So why is that a scalar index? Why is it being seen as a scalar index? We have at inbounds, we're taking the histogram of TID, which is just a random iterator, right? So it shouldn't be that big of a deal. And then we're saying it's equal to the shared histogram of TID. So let's modify this a bit and see what the actual issue is here. So we're going to do yank paste, and we're going to comment this out. And instead what we're going to do is at inbounds of values of TID. Run that. And it's going to give us, let me clear. Oh, come on. Run it one more time, include. Okay, this is going to give us not. So it's indexing over histogram for some reason it doesn't like. I'm not entirely sure why, unless for some reason it's reading histogram in as a CPU array for some reason, which it shouldn't, but maybe somehow. So let me just print out type of histogram down here. So if the event is going to be histogram tag there, should be fine, histogram here. If is a values array, we do that one, otherwise we do a CUDA device. We're reading in a coup array of histogram. I guess I'm just going to do print line type of a histogram. Okay. In expression, it says no memory pool is in use. Got exception outside of at test out of GPU memory. Is my stream still up? Okay. Out of GPU memory, it says. Is it now? Is it? All right, let's do Control C, and let's do watch NVIDIA SMI. All right, how much GPU? Doesn't look like it's out of GPU memory to me. Does not look like that at all. Looks like I only have 452 megabytes being used. I'm not saying I have a lot of GPU memory, but surely I'm not using all of it. Let me just Control C, Control D, run Julia again, and just try it again. What a nice command, NVTop. Never seen that one before. Yeah, I'm trying to use it because I know it's a bit more graphical, but I'm just so used to NVIDIA SMI that I just end up just watching that instead, you know? Is shared memory not freed? No, surely shared memory is freed. I'm not. No way. No way. Right. No way. Okay. So what's the error here? The error is. Okay. Well, first of all, I think the kernel's wrong, right? Because values here is equal to that. Oh, you know what? I think I know what's happening. Okay. No, I don't know what's happening. Never mind. I thought I knew what was happening, but now I'm actually a bit confused. How is A? Oh, it's because we're adding... Okay, let me try this again one more time. Comment that out. DD. Comment that guy back in. DD there. Write this. Go over here. Write it one more time. We should get an error saying scalar indexing is not allowed. I don't understand how, though. What is scalar about the indexing that I'm doing? Give it a second to do like pre-compilation, blah, blah, blah. So it was saying that we were out of memory, probably out of shared memory is what we were out of, which is fine because we were allocating a potentially large amount of shared memory. It's just that I knew that we only needed 10 elements because A was only between 0 and 10, or 1 and 10. Got exception, also test, failed. Let me double check to make sure this is the same error I was expecting. Oh, gosh. Histogram's 38. Wait for the event, of course, is wait on the event. Scalar indexing disallowed. Yeah, that's what I expected. Why? Histogram of TID is shared histogram of TID. So maybe I want to do just a synchronize. I mean, that's something I need to have anyway. What is CUDA synchronize or whatever in kernel abstractions again? Just at synchronize. Okay, let's just do at synchronize. Something like this should work. Okay, try it again. I mean, that's not going to help anything. It's just we needed the at synchronize. Again, we're going to scalar indexing is disallowed. So, what is scalar about the indexing that we're currently doing? That's my question. It's saying if we do histogram of TID, it's saying that is... Oh, wait a minute. Let me think. Is this because histogram is so small? Let me go down here and increase the size of this so it is 1 to 100. Or how about 1 to 128? All right, now we're going to do include histogram again. No. I thought maybe there was an issue with... Okay, what's it saying the type of histogram is? Got exception outside of test. When we print line type of histogram before running histogram tag, so before running the kernel. So this is going to be on line 56, it says, which is obviously test set. CPU, oh, is this CPU errors? No, this is, wait. Down here we have the error. Oh, these error messages are such a pain to read. Let me full screen this guy. Let me write one more time. Let me see if I can read this a bit better. Task failed exception. Is this even failing on the GPU? Like this is, let me just remove the GPU tests for just a second. Is this failing on the CPU? Write this, go over here, run it again. One error. We're getting an error even on CPU code. Wonderful. Great. Amazing. Okay. But... Okay, just hear me out now. I just closed the GPU tests. So how are we still getting scalar indexing is disallowed for the GPU array? I mean, we're on the CPU. Wait. Wait. Yeah, of course it's all the weights. Oh my gosh. So, okay, here's the thing. I really do like kernel abstractions. It's a wonderful, like, easy to use language. The problem is the error messages for kernel abstractions are just a pain. Holy cow, are they tough. It's okay. Like, you'll figure it out, but... And the reason it's a pain is because it's basically taking the code that you've written, and it's converting it into a CPU or GPU form. It's complicated. It's basically the short end of it. Okay, so where is the kernel call? All right, let me try running this again. I'm just going to print something else. Print line type of histogram. And we're going to say, in all caps, type of histogram. Let's see if we can even find that in the error message. Write this, go over here, run it one more time. Type of histogram, coup array. Perfect. Okay. Why is it a coup array? Oh, because I'm an idiot. That's why. This needs to be if is a array if is a array values, and then we need to swap these guys. So D2D paste D2D paste. And then we need to go up here and we need to say if has CUDA GPU. Try running this one more time. We still got an error. Is a expected type of value in 64. I maybe just forgot how to use is a. Okay, look, we're getting there. One step at a time. We're definitely getting there. Okay, nice guy 0000110. Not sure if I said the correct number of zeros, but thank you so much for following. Really appreciate it. I like nice guys. They're nice. But a shorter error. Yes, shorter error. That's what we're getting at. Okay. This one is because I don't know how to use is a apparently. So is a values array. Okay, that's the problem. I did is a array values. So here we're gonna do values array. And DT here, write that, go over here, run it. Okay, it failed. Rather spectacularly. Did we get a failed test? Wait. Let me show you this. Let me make this huge. Okay, here's the problem. We have -145, and we're comparing that against 13. So look, we're definitely in the wrong here, but like we're getting there. Slowly but surely, we're getting there. Okay, so let me run the GPU test as well. DD here, DD there, and hopefully... Okay, we got an error. And this is not the scalar error, which is wonderful. Perfect, okay. So what is the error then? It's a check IR error. My word. Huge. Move this over here. Okay. Oh man, you know, whenever I start programming for the day, you know, I have like a list of things that I want to get done. I'm like, let's just do this, you know, I'm gonna get all this done today. And in a perfect world, I would get all that done. But the perfect world does not involve real code. The perfect world is all pseudocode that just magically works. Whenever you actually have to write real code, right? Okay. Exception outside of test, invalid IR resulted in invalid LLVMIR, so that just means there was a typo. The typo has to be, I know which line the typo has to be in, so let's just kind of mess around a little bit. Let me see if I can just get this to run. Even if it doesn't work, I just need to get it to run. So we're going to do this, and we're just going to comment that out right there and go here, histograms. Still doesn't run. Crap. Is that because @synchronize is not a thing? Let's go to huge. What is the error? Gosh darn it. Error outside of test. Invalid LLVMIR. Apply type. Unsupported call to the Julia runtime call to JLF apply type. When are we applying a type? Is this in the shared memory creation? Okay, I guess let's just mess around until this works. Is it this one? It's clearly not at index. At index is gonna work just fine. At inbounds, shared histogram. Then it has to be this one, right? Where we create some sort of shared histogram. Yeah, it has to be that one. That's the only one it could possibly be, because that's the only one where we actually write a type down, right? Do we have to configure the kernel with shared memory? The answer should be yes, because if you're going to do this with any CUDA system, you often have to pre-allocate the array for shared memory. But I don't know how to do that in kernel abstractions. So what I'm going to do is I'm going to go to default size here. I'm actually going to look at some old code to see how we did it in Klima, because it's just been a long time, like a super long time since I did any of this. And I just really don't remember how to create these shared tiles. So quit here, cd projects, Klima, ls here. What am I looking for? I'm looking for kernels. What am I looking for? I'm looking for where we configure the kernels. So let me do grep-rl, and we'll look for local mem. Obviously abstract kernels.jl. Right, diagnostic fields. Right, DG methods, DG model kernels. Right, let's go there then. So let's go into VI source, numerics. Let's do DG methods, DG model kernels. Let's look for local mem here. And now what I want to do is see where this is called. So I'm going to look for volume tendency. So grep-rl volume tendency. How do you spell volume? There we go. We're going to go into DG model, source numerics, DG model.jl. I'm sorry, guys. And now let me look for volume tendency. Let's see. If we don't operate this full scale, launch volume tendency. Right, so where's the launch created? Launch volume tendency is here. Oh man, look at this Unicode. Should I reopen this in a different terminal with Unicode support? The answer is probably, but I'm not going to. We have DG, tendency, state prognostic, T, and then Unicode. Okay, fine, I'll reopen this in Unicode, screw it. All right, so I'm gonna open up UX term this time, make it huge. Move over here, over there. Okay, CD, projects, Klima. I should have it there. Okay, so now what I'm gonna look for is launch volume tendency. I just really wish there was an example of using shared memory in kernel abstractions. That's the thing I wish there was. So maybe, sorry about that, maybe what I'm doing right now is just creating that example. And maybe I will just give this example to kernel abstractions and be like, hey, here's an example of creating a histogram using this method on the GPU. And just be like, hey, it is a very simple example of using shared memory. That's all it's for, right? Okay. Launch volume gradients, launch volume tendency, launch volume gradients. I'm looking for the size of shared memory, and seeing if we have to configure that beforehand. So actually, let me look for CUDA device. That's actually what I want to find. Array type is going to be CPU or GPU depending. So CUDA device. Ooh. Okay. Right. That's fair. But this means that we're going to look for device now. Okay, so event on device and then kernel init state. We're going to take device. And then I believe the next one. Oh, that's the number of threads, right? Yes, that's the number of threads. ND range, and then dependencies. Crap. So it doesn't look like, Marky Pop says, thank you so much for following. It doesn't look like we're actually reading in. It doesn't look like we're pre-configuring how much shared memory we need to create. And that's what I was afraid this error was. Again, the error is quite long and very difficult to figure out. If we figure it out today, I'm gonna be happy. Like honestly, we went from, I'm gonna fully implement all of these histogram methods today, it's gonna be amazing, to let's just figure out this one error. But that's the nature of programming, you know? Like it happens. All right, what are we doing here? So the actual error that we have here is what? I think I know what lines. Okay, well, let's see if the shared memory is actually the problem here. So what I'm going to do is I'm going to make this default, move this down here, and I'm just going to start commenting out other things. So I'm pretty sure TID isn't an issue, but I'm going to comment this out, and we're going to run it one more time. We still get an error, and I just want to check to see if this is the same error as before. It is very difficult to tell. Compiling kernel, I'm looking for compiling kernel, GPU histogram tag kernel, cassette, nothing. Unsupported call to Julia runtime, JLF apply type. Okay, so maybe what I need to do is give it a specific type up here. So 64. Well, okay. First of all, let's check to see if this is the line that's actually causing the error. Oh, what? Where's the equals? What did I do? You here. There we go. I need that. Alright, try it again. Okay, is this still giving us the same error? In which case, then, yeah, JLF apply type. So I was actually sniffing up the wrong hallway. Is that a phrase? Pretty sure it's not. Add synchronize? This one? Okay, well, we're getting errors all across the board. TID not defined. What? Just comment out the whole kernel. Screw it. Okay, let's go. Commenting out the entire kernel. If we still get an error, then we know it's not the kernel's fault. Okay, we still get an error. Wonderful. Okay. And it's still getting the error to JLF apply type. What are we applying a type to? Okay, let me close Julia and open it back up again. Try running it again. Who knows? Right. Okay, because has CUDA GPU is only available if you have CUDA. We're just gonna screw it. Screw it. That's what we're doing. Not worrying about that one. All right, let's see if we can get an error. See, now I'm just hoping for an error. Like, I really want to get the same error we got before, just to prove that this isn't an issue with the kernel, right? Because if it is an issue with the kernel, then I'm not sure exactly. No, yeah, crap. Okay, well then let's just see what happens if we define a shared memory tile. We're just gonna move this in line by line. Perfect. Shared memory seems fine. I'm going to say that this one's also fine. Okay. Look, we're failing the tests, but fine. Histogram, all right, perfect. Synchronize should also be fine. I don't see why that would break. All right, perfect. So obviously the issue is in this loop here. Why are we not getting error? What's going on? What? Okay, don't give me that. How? Okay, well, look, Harry Hopkinson, thank you so much for following. I turned it off and on again. That's what I did, and now it seems to be working. So that says to me there's something wrong with the compiler infrastructure, that it didn't catch that we updated a kernel. It's complicated. I really don't know. So now, all we're going to try to do is make our crappy kernel get somewhat relevant values. That's what we're looking for. I don't know if I fixed it, but we're getting failed tests instead of errors, which means the numbers are wrong. Not that, so the numbers are wrong, not that the kernel is fundamentally broken. So that's something, I guess. Okay, so give me a second. Let me just, okay. If we can just get this stupid kernel working, that's it. That's what I'm looking for today, just getting this kernel working. And if we get it working, It's not the kernel we were looking for, but it's the kernel we deserve. You know what I'm saying? Like, it's what we got. And I'm sorry, guys. I don't know what I'm saying, actually. Like, please, just ignore me. But my point is, like, if we get it working, we can build on it. Like, that's the point. This is a crappy kernel that we build on. This is not the end goal. This is a test, right? That should get sufficiently close to the actual histogram that we're looking for. Right now, we're not sufficiently close. We get 0, 0, 0. And we're comparing that to 9, 5, 8, all this kind of stuff. So here's what I'm going to do. I'm going to run the CPU kernel and try to get that one working. And once we get the CPU kernel working, my assumption will be that the GPU kernel will... I mean, it's a dumb assumption, but I'm gonna go with it. If the CPU kernel works, the GPU kernel should also work. It's the same code, right? Like, if it works on one platform, clearly it works on all platforms. I say knowing full well that that's not how this works. Okay, so let's go here, comment that out. Go over here, comment this out. And we're just gonna run it one more time to make sure we get a failed test. Perfect, one failed test, but only one test done. Okay, so what do we do? What I'm gonna do next is we're pulling out the CPU tag histogram. What I want to do is mess around with things, see what we can do. So we're calling histogram tag with a bunch of values. Where are we? Histogram tag kernel, and we're returning back histogram. So the way this works is we create the histogram array, which is just going to be zeros of int. We should probably make these zeros of int 32. And then we should probably make this also int 32, just to make sure that we're not doing any weird floating point precision issues or anything. Not floating point, but, you know, like precision issues between converting from 32 to 64. That might have actually been what the error was before. Like, we had created histogram, which was of type int 64, and then we were trying to copy int 32 bits to it. That could have been what the error was. Okay, so we're still getting a failed test, but nothing. We're still getting a failed test. Okay, let's just take a look at what the histogram actually is. So we've got this test in here. I'm gonna just run it in the REPL and see what we can get. So here I'm gonna say A is gonna be equal to rand, this guy in here. Okay, perfect. And then we're gonna do final histogram is equal to this, just so we have it, and I'm gonna plot that. So let's do using plots. Okay. And again, I'm not really a big fan of how I'm like wrapping all the functions up. I think there's way easier and more efficient ways to do that. So let's plot final histogram. There we go. Give it a second to precompile plots. We'll get something that looks like something. It's not going to be pretty, but we'll get a plot out. And then once we get that plot out, we're just going to try to replicate that plot. And so then I'll create the CPU tag histogram, and we're just going to look at the difference. Sure. Okay, so here's the histogram we're trying to replicate. It's not a pretty histogram, but it's what we got. CPU tag histogram. Okay, and now let's plot that. 1 second. Okay, sorry. CPU tag. Okay. All this is telling me is that shared memory is not initialized to 0, is essentially what it's telling me. So, yes, we just initialize it to 0. Can we initialize shared memory to 0? I guess we can, right? Like, I guess anytime that we... Oof. Okay, this is going to be a really ugly kernel, but I'm going to do it, and you guys are going to have to just deal with it. I'm going to put this in here. I don't like this at all. We're going to paste it actually above. And then we're going to set all the shared histogram equal to 0. I really hate this. I hate this so much. We're wasting so much computation here. But, like, I'm just trying to get something working. And I'm just going to put a quick comment in here. Please, for the love of God, don't do this. I'm sorry. Change this. To do something, anything but this. Okay, good. All right, so we're gonna do write this, go over here, and we're gonna run it again, include. What happened? What happened? No way. So we're initializing the histogram. I'm gonna do the following. I'm actually gonna comment this out. Over here, histograms. Okay. So what I did is I set all the histogram elements to be 0. That's what I did. Let me close Julia and open it back up again. Maybe initialize Facebook? How do you initialize Facebook? I'm gonna delete this line and we're gonna REPL it for a bit, guys. Go in here, comment that out, include, and then we're just gonna define all the values and see what we can do. Maybe the constant definition of the kernel is kind of giving us issues. Because again, GPU compilation is a bit finicky, so maybe, I don't know, maybe that's an issue. When you say histogram, it sounds like Instagram. I mean, I guess, to be fair, I've never had an Instagram, and I don't think I ever will. Same like I'm interested in TikTok. The thing is, I've never actually been on the site. I've never looked at a TikTok before. I've seen like a few of them on Reddit when they're posted there, but that's about the most I've seen of TikTok. I am interested in the platform because it seems to prefer shorter videos, like short content, which I also prefer. So in some sense, maybe TikTok would be the ideal platform for science communication for me. Maybe I should stop my YouTube channel and just put everything on TikTok and just make it so like that's where I build my platform. But again, I've never been on TikTok before, so I've got a feeling that's a very bad idea. Anyway, we're going to define A is equal to this, and then we're going to define final histogram is equal to that. We're going to do using plots. We're going to do plot final histogram, and we're going to go from there. Give it a second to do all the pre-compilation. Plot final histogram. Okay, and this should be like 128 elements or something like that. I'm just double checking. But actually, I'm kind of interested. Do you guys watch? Like, what do you guys watch outside of Twitch? I mean, I assume, and I'm not sure, but I assume you guys probably watch YouTube, because I assume that's actually probably why people are here, because they've seen my YouTube channel for the most part. I don't know if that's exactly true, but I assume that, you know, if anybody's watching, probably they have seen my YouTube channel before. Then there's also, you know, what else do you guys do? I mean, probably Twitter, Instagram, maybe, Reddit, maybe, I don't know. You could try YouTube Shorts. I thought about that, actually. I thought about just putting all my animations under YouTube Shorts. I don't know, but I didn't do it because I didn't have the guts to do it. Okay, so now we're going to do, what is it, CPU tag histogram. Give it a second to do everything. I don't get it. I don't get it at all. Why? So we have the histogram tag here. Sorry, where's the kernel? Here's the kernel. All we're doing here is we're creating a shared memory tile, which is local mem int32 length of histogram. Then what we're doing next is we're saying if TID is less than or equal to the length of the histogram, we're saying histogram of TID is equal to 0. So we're wasting a bunch of threads, like a whole huge heaping load of threads. We're wasting all of them. And we're saying just the first 128 threads, please set our histogram to 0. We're wasting all of the threads, that's fine. We're then asynchronizing. We're doing nothing. We commented out the next line. And then we're just saying, okay, we're going to copy everything from our shared histogram, which should have been set to 0, onto histogram TID. And it's not working. I mainly watch YouTube, TikTok, Instagram, some sort of Reddit, and quite a bit of Twitter. Interesting. So I actually don't go on Twitter too much. I post a bit on Twitter. Let's see, what else do I do? I don't really watch YouTube too much. Like, if I watch a YouTube video, it's under 5 minutes, and it's also at 2 times speed. Does TikTok have 2 times speed? If it does, maybe it's worth watching. TikTok videos can be at max 3 minutes long, if I recall correctly, and videos get taken down all the time for no reason. Well, that's probably an issue. Okay. So, maybe I do an at print and just see what's going on here. At inbounds histogram TID 0. Presumably all of the... Oh, I'm an idiot. This should be shared histogram. Include CPU. There, now we get all zeros. Perfect. That's what I wanted to see. I don't like this, but that's how we did it. Write this, go over here, CPU. Okay. Inbounds shared histogram of values of TID. Okay, so, right. We now have an array of all zeros, which is something. Let's see. What do we have here? Twitch and YouTube for me. Try to stay away from other social medias, but sometimes Reddit is handy for finding answers. Right. So I tend to find myself browsing Reddit more than I browse other platforms. I think it's because there isn't a video component, and there isn't always a video component, and you can watch it somewhat silently. I don't know, I don't always have the mind share to watch a video. In fact, I rarely do. But Twitch is nice because it doesn't require too much mind share. Maybe if you can make binary tree dancing, that would be a good idea. I hear that TikTok's about dancing people. That's all I know. In YouTube, I watch either 5 minutes or 1 hour plus videos, almost nothing in between. That's fair. TikTok creators can accelerate things, but I didn't find a speed up option. Interesting. Okay. So what is the issue here? At inbounds shared histogram of values of TID is going to be plus equals to 1. That's what I'm looking for here. And that doesn't seem to be happening. Let me try plotting this really quick. Plot CPU tag histogram. It is all zeros, identically zeros, which means, write this one more time, include. Oh, we got some ones. Oh, this is not good, but we got some ones. Now what we're trying to replicate, remember what we're trying to replicate is this one. So we got pretty close. we need like an average of 10 values across the board, and we got like 3 total. So like, we're getting there. Okay. At inbounds shared memory histogram values TID is plus equals to 1. Yeah, we're getting there. Slowly but surely building our way there. Is this the issue? No, that's not the issue. I thought like, So if TID is less than length of histogram, I hate this. I hate that so much. There must be a better way to do that. I don't know, but I'm gonna find it. There has to be a better way to initialize the shared memory to 0. Juan F89, hey, how are you? I'm having a great day. Can I just copy? Okay, let's not worry about it for now. Let's just do it and not worry about it. Okay, so at inbounds shared histogram values of TID is plus equals to 1. So basically we're going through all the values of values TID. Do you like math? Yeah, I'm okay with math. I like math a good bit. It depends on the type of math. Like if you're asking about like heavy proofs and stuff like that, I'm not super big into, super heavy proofs and stuff like that. But if you're into like algorithms and computational science, yeah, I'm into that. What is values? Values is this. It's just a series of like, we're trying to count how many 1s we have in the array and how many 2s and how many 3s and 4s and so on and so forth. So it's just a list of random numbers. But that's a good thing. Let's double check to make sure that it's being read incorrectly. So we have CPU, we have values here, we have A, and we're reading in histogram tag. Where's histogram tag here? And it reads in values. So histogram tag here does the histogram values. I'm going to do something really stupid here, and I'm actually going to print line values here. Just to make sure there's nothing weird going on. Values. All right, let's do include CPU tag. Okay, so there are all the values. It's just a list of random numbers. If you like math, do you know Haskell? I mean, look, I know of Haskell, but I've never actually used it. To me, I think Haskell is too mathy of a programming language for me, if that makes sense. I don't know if that's true. I just know that people who really love math actually really like Haskell. But for me, I find it a little bit unintuitive. I actually prefer less functional styles. Not that there's anything wrong with functional styles, it's functional programming languages. It's just that for me, it's a bit easier for me to read like empirical code, just because that's what I know. And oftentimes I'd have to transcribe. I would have to transcribe the wait a minute, I'm thinking. Anyway, I'd have to transcribe the math that I saw into some sort of empirical code in order to understand it. I just didn't hear about Haskell lately and where people use it. So it's used in, the thing about Haskell is, okay, this is stuff I don't know, but there's a type of safety to Haskell. So any type of critical systems, I'm saying stuff that I don't know about, but any type of hypercritical system you use Haskell for. It's even too mathy for me, and I was a math major. That's fair. Now, I know some people who swear by Haskell. They're like, this is the best language ever, and if anybody tries to tell you differently, they don't know what they're talking about. People say that. Let me do, can I do int 64? How about int 32 of this guy? Let's see if that does anything. Include. Oh, actually, I need to redefine a. A is equal to this, and now we're going to do int 32 of this guy. Oh, hello. There and there. And now we're going to do this all over again. So now we're going to do final histogram. Okay. And I'm going to do CPU tag histogram. Okay, that didn't help at all. It did nothing. I tried. Haskell is fun. But the compiler can be less than helpful with its error messages sometimes, and you'll get many error messages. Yeah, but what language isn't like that? I mean, have you seen Julia's error messages? They are way less than helpful. Some of them sometimes are helpful, but a lot of them are not. Okay. So what's going on here? We have a set of values that are being read in, which is totally fine. Let me make sure that's actually A. Yeah, it's definitely still the value of A. We're putting line values. ND range is size values, which should be fine. Are we doing something wrong with the TID? Is the TID not going through all the values appropriately? Maybe. I guess I can just @print TID and see what's going on. Hey, Anakin Luke, how are you? So let's go ahead and DDDD, write this. And let's use @print with kernel abstractions, which I helped implement actually, and I've completely forgotten how it works. @print. Maybe it's somewhere in here. @print. Perfect. No! Ah, crap. Okay, well, let's do an @print in here and see what we can do. Histogram tag over here, and let's just run @print TID and see what happens. There's no way. There's no way this is gonna run. Oh, but wait. It did. Let's see what's going on here. @print TID. Do I have to turn it into a string? Maybe. I don't know. I'm just kind of messing around here. How do I do this? Is this sprintf logic? No way. No way. This is not gonna work. Yeah, I knew it was gonna work. Okay, how did we do @print macro? How does that work? Okay, let me go to. Does this project with fractals have anything to do with Grant's recent videos? No, it's nothing to do with that. People should start use status code 418 instead of 404. Wait, oh, for this guy? Where is 404? Here? Okay, so I'm gonna go to kernel abstractions here. And we're gonna go here. I'm actually just gonna look at the source code for @print. Source, extras, loop info, nope. Macros here, @print. Nope. Okay, let's go into my local copy of kernel abstraction, see if I can figure this out. cd back into kernel abstractions, grep -rl print. Oh, but it's in tests. Oh, but probably because of test, because of like print line. Examples, naive transpose, CUDA, kernel abstractions, vi source, kernel abstractions, .jl, and let's look for print. Okay. At print items. Okay. So can I just do at print and then let's try this. I don't know if this is going to work, but if it does, I'll be happy. Include CPU tag histogram. Okay. It didn't exactly do what I thought it would do. Let's do this. Include CPU tag histogram. Ah, there we go. Perfect. And look, it looks like it's basically 1 to 1,000, which is what we expected. Perfect. So it is going through all the TIDs. So the next thing I'm going to do is I'm going to at print values of TID. Okay. This looks like it's correct. I mean, it looks like it's going through all the values just fine. What do I miss here? Did you move to EU? Yes, I'm now in Barcelona, so that's where I'm currently living. I'll be here for the next few years, and yeah, we'll just see how it goes. Weird. So, okay, look, I mean, we're going through all the values of TID in here, right? And they're iterating through just fine. I'm going to change what this at print is at and move it down here. There's no way this changes anything, but I'm going to do it anyway because I'm a bit confused. DD here, write this, go over here, include CPU tag histogram. Yeah, they're going through just fine. And so, for example, here's 120. So we're saying shared histogram of 120. So let me just output the length of... all right, let me just do an at print in here. I don't know, I'm a bit confused here. If TID is equal to 1, and here we're going to do at print, and then we're just going to do length of shared histogram. All right, and then we're going to do new line. And also, let me just put a string in here. And so we're going to say, I confused with Brazil. Yes, in Spain. Yep. So we're going to say length of shared histogram. Sure. All right. Let's do include CPU tag histogram. Scroll up. Okay. Let's remove this at print statement in here. Include CPU tag histogram. So 128. So we have up to 128 values. Okay, equals 1. No, why? How? How? Okay, so we have 128 values in our shared histogram, right? We just checked. We literally just checked by saying this guy in here, at printf, length of shared histogram, 128 values, right? So then we have a list of different array elements in here. Anonymous Cheer, thank you so much for the bit, really appreciate it. So then we have, what is values of TID? That is this guy in here. So values of TID. So right, what we're doing here is we're creating a histogram. So the values are just like a whole bunch of randomly assigned integers. It's like, you know, just a random uniform distribution, essentially. And so it's just a list of values from 1 to 128. And then what we're doing is we're just trying to count how many 1s, how many 2s, how many 3s. So if values of TID is a 2, then we want to increment shared histogram of 2 here. So what's the next thing I'm going to do? I guess the next thing I'm going to do is we have that. We have TID. And we're going to do include CPU tag histogram. I'm going to print down here. Screw it. Let's just keep doing the print debugging at print. And we're going to do histogram, shared histogram of TID, and then new line. Okay, include CPU tag histogram. Where did that print? Wait 1 second. Let me remove this at print in here. Write that, go over here. Include CPU tag histogram. Okay, it is all just a bunch of zeros with a few ones in it. Okay, so then there's something wrong with this guy in here. Now, this could be a parallelism issue. Real00, thank you so much for following. Really appreciate it. Could be a parallelism issue because you could have multiple threads. This is on the CPU. It can't be a parallelism issue. This is on the CPU only. So that can't be the issue. We're going to, at inbounds, shared histogram of values of TID is going to be plus equal to 1. So if the values of TID is 77, it's shared histogram, which has 128 elements. There's no debugger for this, unfortunately. Or rather, I'm trying to debug it, but there's like... I mean, I suppose I might be able to open it up in RR, but like for GPU debugging, I mean, the best you can hope for are the... I guess I am on the CPU now. Anyway, let me keep messing around here. 1 second. Can you show values of TID again? Yep. So we're going to do include CPU histogram. So the values here are just ranges. So 74, 73, 103, 78. It's anywhere between 1 and 128. And there's 1,000 of them. So maybe 1,000 is too high, but I don't think so. I mean, it's in 32. Values of TID. Oh, wait a minute. There are some zeros in here. Why are there some zeros in there? Okay, wait. Maybe that's the issue. Maybe there's zeros in there. I cannot plot it. No, I cannot. Yeah, I can't plot it. Sorry about that. Is this because of our at inbounds check? Because we're using 256 threads. Right. So let me try one more thing. Maybe the issue is that we need to say the following. So this guy, what we need to do is say if TID is less than length of histogram or values. I thought that would be it. Yeah, I can't print them because I can't output them. That's literally the problem right now. So values being read in is fine. I can print that right now. So if we do plot of A, that's what we're reading in as values, which is totally fine. But the issue is when it's being fed into a kernel, it could be something else. So that's the problem with this. So, but it was a good point to plot to print the values here, because if I scroll up to the values, I noticed that there are a few zeros way up here. Oh, wait a minute. There are no zeros this time. Oh, wait, no, yes, there are. Here are some zeros. I don't know how those zeros got in there. But there are definitely zeros in there. And my guess, what is A? A is int 32. Is there like some weird 64-bit nonsense going on here? Let me control D, Julia 1.6, and I'm just going to redefine everything. So we're going to include everything again. We're going to set A equal to an int 32, definitely an int 32. Int 32 random 128. And then the next thing I'm going to do is run final histogram using plots. And then 1 second. Give it a second to build. And I'm just going to plot some things, mess around. Why were there zeros up there? The only thing I can think of for the zeros is that maybe it thought it was a 64-bit array and it was trying to output 32-bit values or something weird like that. You know, like, I don't know. I'm not really sure. Okay, so the next thing I'm going to do is plot A, which should be fine. Let me get some more water. By the way, guys, I only have 45 more minutes left in stream. Still some time. I think we can still figure this out. But I cannot go beyond 6 today. I'm just letting you guys know that. So as we start moving up to 6 o'clock p.m. my time, which again is in about 45 minutes, if there's anybody live that you want to raid at the end of stream, just let me know. But I'm sure we can get at least the simple thing working. Uh-oh. I think we can get at least the simple thing working in 45 minutes, like surely, right? So let's do CPU tag histogram, and this should output, yes, it should output a bunch of values. And let me scroll up to see if there's still zeros in here. Way up here, there should be some zeros. There they are, look, zeros. So what I'm guessing is that it gets one of these zeros and just stops executing. So if is less than that, and I guess I'm putting an and, TID, values of TID, 1 second, is greater than 0. Include? What happened to Rust? Include CPU tag. Dang. Okay. Yeah, did something happen in the Rust community or something? Okay. Right, so we have at synchronize. The synchronize shouldn't do anything. Let me do something else then. So what I'm going to do is at print the values up top. Oh, you know what I could do though? I could... wait, I need to think here. So values of TID. Okay, so what am I reading in as values? So I'm reading in as values over here. I can set values of TID equal to values of TID is what I could do. And then that would allow me to see if there's anything funky going on. So let me try that. So the histogram tag kernel. Wow, this is a mess. TID here, I'm gonna comment all of this out. Here. And over here as well. And now I'm just gonna say the following. What do we have here? I guess writing programming language is about the experience and not about how it looks. So I looked at Rust, and by looking, it looks weird, but the experience could be different. Right, so a lot of people see Rust as a C competitor, more or less. For what I see, C and C++ competitor. In which case, I will say that probably the Rust syntax is better than C++ syntax from what I've seen. It has a package manager that makes, the hardest part of C++, which is the compilation, way easier. And there's a lot of nice guarantees that you get with Rust. So for that purpose, I think it's actually quite nice. Is it useful for the stuff that I'm doing? I really don't know. I've never really seen people using Rust in computational science, so I also am not using Rust. Maybe it's like the perfect language for everything, but it's just not really in the scope of what I see people talking about. Are there random unwanted zeros in shared histogram TID or values TID? Right, so that's what I'm trying to figure out. What I don't grasp is that shared histo is in local memory, but you don't sum all the local memory into global one. That's what this is doing down here. So down here what we're doing is we're taking all the shared memory. So at inbounds histogram of TID is equal to shared histogram of TID. So that's what we're doing down here. Hey Prutz, how are you? I learned Rust this summer, it's very good. Good, so that's one data point. Actually multiple data points. A lot of people in the algorithm archivist community really like Rust. What is weird about Rust for you? For me personally, I don't think anything's weird about it. I just don't know enough about it to say any comments. But I think you're talking about Meowcat up there. Okay. So what I'm going to do next is I'm going to say, you need the local ID. Wait. You need the local ID, not the global TID, right? It's probably very different from what is weird about Rust for me. Right, so that's why I'm doing this stupid thing. Right, I'm doing this really stupid thing of just saying if the TID is less than the length of the histogram, so that we're only doing like the first 128 threads are only being used here. That's not ideal, but it's just what I'm doing. Again, that's why I say to do anything but this. I don't actually know the way to do a local index over the shared memory. That's something that I'm not quite sure about. Yeah, I need to look into the indexing for kernel abstractions for that. Okay, so what I'm going to do next is I'm actually just going to do the following. We're going to say values are going to be equal to, values of TID. It's going to be equal to values of TID. I don't understand why this would be an issue, but I'm going to do it anyway. So we're going to do include. And then what I want to do at the end here is instead of returning histogram, I want to return values. Well, okay, so now we're going to run histogram tag again. So we're going to include that. We're going to run CPU histogram. I'm going to change the name just to be A2. All right, so now I'm going to plot A2, which is going to be, it's going to look fine. There's no issues there. Okay, so now the next thing I want to do is just output all the values and scroll up a bit and see if I can find those zeros again. So now we're going to grab this line in here, yank. We're going to paste it down here. Write this, go over here, include one more time, and we're going to run this one. Okay, so now we have all these values, and I'm going to keep scrolling up. And right, there are no zeros in this. Yeah, there are none. Now, what I might have done is something really dumb here. And I might have accidentally set some of the values to 0 somewhere else. So I'm going to D2D in here, DD there, and I'm going to DD in here. Go over here, return. We're going to return the histogram again. And we're going to do include. And now I'm going to run CPU tag histogram. I know what's happening now. I know exactly what's happening where those zeros came from. Okay, we're putting the values here. But I'm also doing another print. Where are the other prints? Print. We have print there, and print here. We're printing the shared histogram. Maybe the synchronize isn't actually blocking anything. Maybe that's the issue. Yeah, that could be the issue. Maybe it's not actually acting as an appropriate barrier. And that's why we're getting zeros. So here's what I'm going to do. I'm going to run it twice. Oh man, if that's happening, I'm going to be pretty pissed off. And that's why all the zeros come up here. Do we see any zeros? Am I just... Oh, there they are. Here's the zeros, right? Zeros are right there. So let me comment out this line. And let me try it again. Scroll up. Oh, this doesn't make any sense, does it? There will still be zeros up here, right? No. No, I see no zeros. Dang, that's super annoying. Okay, so what's happening is this synchronize is not acting as an appropriate barrier. It's not stopping the actions from happening. Okay, great. So at least we know that's the issue, or pretty sure that's the issue. I'll be dealing with a Rust-based block change. Okay, so why? Why is this not stopping anything? Let's look at synchronize in... Let's look at it. I don't understand why not. But see, we do have this at synchronize dim equals 3. I'm not sure why we have dim equals 3 there. What are you at synchronizing for? Yeah, I don't know. I honestly have no idea. Right, is the at synchronize only acting on the local and not the whole kernel? I don't know. I don't know what at synchronize does then, if it doesn't like act as a barrier, right? Kernel abstractions, Julia. Look at the documentation, see if I can figure this out. Maybe I could do at methods for at synchronize. I'll catch up on chat and just give me a second. Sorry, I'm a bit frustrated with that. Okay, so let's look for at synchronize. Z. At synchronize. Platform differences. So after at synchronize statement, all reads and writes to global and local memory from each thread in the workgroup are visible from all threads. Okay. Should be fine. Usually you don't have a primitive call to kernel barrier within the kernel. Oh, you have that a lot. What do you mean? Sorry, maybe I'm misunderstanding your comment. So I thought Rust would feel like Haskell. Oh, I missed a lot. 1 second. I'm missing a whole bunch here. Why not? I'm interested in anybody's experience. I'll be dealing with... Oh, 1 second. Let me change the lighting as well. Sorry. Sorry, it was getting a bit dark. What do we have? Are we dealing with Rust-based block change? It's way different than C++. The syntax is one factor and features, like I saw something like tokens, and I haven't heard of it before. That is what I say for someone who writes mostly Haskell. Now Rust feels very C++-like. Right, well, that's fair, right? Because it's more of well, it's not a functional language, right? So things are different and weird for me. Is the synchronized only acting on the local? I thought Rust would feel like Haskell, less C++. Usually you don't have a primitive call to kernel barrier within the kernel. Again, I do see that a lot though. So I'm a bit confused by that statement. So let's see. Like in C++, for example, you use it all the time. Like if you're doing like a transpose or something, you have to make sure, or like a summation or something. In fact, maybe they have a, they do not. Crap. Okay. I was really hoping they had a kernel that gave you something more complicated, but that's okay. Plan to write one for Rust. That's for someone who's more used to C++ rather than Haskell. What about the block change? I plan to write one in Rust, or maybe Ruby, not sure. I know that e.g. the Golan blockchain is written in Rust. You spot differences with what you are most familiar with. Solana, I want to do some trading there. 1,000 transactions per second. Interesting. This is all stuff I don't know anything about. I'm sorry about that. Okay, let's just see what they're saying. After an @synchronized statement, all reads and writes to global and local memory from each thread in the workgroup are visible from all of the threads in the workgroup. Sure. Okay. We should adopt this term for something. Right, so at private is not what we need. Right, let me think. So, okay, what's actually happening here? So, okay, maybe I mean, like, you see the @synchronizes a lot in, like, parallel summations and stuff like that. So maybe there is a parallel summation code written somewhere that I can look at and see how they're using @synchronize. After @synchronized statement, all reads and writes to global and local memory from each thread in the workgroup are visible from all of the threads in the workgroup. Condition is not allowed to have any visible side effects. Okay, so, hey Husky, how are you? How do you know what is print? Maybe print something at the start to confirm. Gotta go. Have a good rest. Yeah, see you, Trash Talk. Have a wonderful evening. Okay. So, synchronize only occurs if the condition evaluates. Okay. So, we have the essay. All good on that unemployment life right now. How are things here? Things are okay. Yeah, I didn't realize. Yeah. Hey, Nick, how are you? Okay. So we've got, I'm sorry, I'm not finishing any of my sentences right now. I'm so sorry about that. I'm kind of like a bit fried. So I'm trying to have like consistent, coherent conversations, and I'm just failing miserably at that right now. And I apologize for that. But yeah. Okay. So we're printing the shared histogram. 2 months ago, Solana was up 20 per coin, and now it's at 162. I wish I would have known in advance with coins and increase. Honestly, when it comes to everything with Bitcoin, way back when Bitcoin came out, like I was in college or something like that, and I heard about it. I was like, ooh, that sounds like a super good idea. I wish I could invest in it, and I really wanted to invest in it. And then I didn't because I was a broke college student. I didn't have money. If I were like now, if I was, if Bitcoin had just come out now, I would definitely invest in it. It sounds like a really cool idea. But I didn't. And now it's used for gambling and everything. And I kind of wish it wasn't so gambly, Like that's the one thing I don't like about it. It's not, used so much as a currency as it's used as a, investment or something, Okay. So, speculation. Yeah, something like that. Yeah. Okay, so we set it equal to 0. Is there a logic writing at synchronized before if statements? What do you mean? Sorry. So the whole point of at synchronize is to act as a barrier, right? So that it stops everything and waits for all the threads to finish acting before it goes again. But maybe there's a separate barrier command here. No, there's not. Let's see. Yeah, crypto is ruined by speculation and flaws in V1 Bitcoin. Yeah, that's fair. Okay, so yeah, I mean the at synchronize should literally just stop the operation. It should wait for all the threads to finish whatever operation they're working on, and then it should keep going. And that's all. I just wanted to make sure that we set all the histogram values to 0. Right. Yeah, I understand it's sync threads, but in Julia, I think it's just at synchronize. I don't think there's a sync threads, or in kernel abstractions. I think it's just at synchronize is sync threads. So that's what this call is doing. Right. It should be the same thing as a barrier in OpenCL as well. Should be. But I mean, maybe there's something weird going on. Okay, so I guess I actually don't even know where to go from here. If I'm being honest. Because I'm pretty sure the logic there makes sense, unless I'm missing something, right? Which clearly I am, right? So what's happening here is where obviously the execution is not happening sequentially, right? Obviously what I wanted to have is this block occur, then this block occur, and then this block occurs. That's what I wanted. Clearly that's not happening. So clearly the synchronize is not doing what I thought it would do, right? So now the question is, how do you do that? Again, in C++, sync threads is what I would do, which is what at synchronize does. I was wondering if at synchronize is even related to what's in the code before and after. Well, again, at synchronize should just stop the execution of all the threads until like basically it waits for all the threads to finish their action before continuing. That's what it should be. But that's clearly not happening, which is why I wanted to see if there was like a simple summation code or something that I could look at to check to make sure that I'm actually doing this correctly. Yeah, like if I could get a parallel summation, then yeah, let's see if there's an example here. Kernel abstractions here, kernel abstractions.jl. Examples, is there anything here? Memcopy set, MPI, naive transpose, performant mapmul. Maybe here? Tile dimension, uniform, sure. So I'm looking for at synchronize. Okay, maybe it just needs to be this without this. No way, this isn't gonna be it. I'm just kind of out of ideas. Yeah, I'm totally out of ideas. You'll figure out what the issue is right before you fall asleep. Happens to me all the time. And what if you remove the second synchronize? So right now, I don't think the second synchronize... Wait, why do we want to remove the second synchronize? Maybe use another at synchronize? I mean, I can, but I don't... So, you comment. I mean, it does basically the same thing. Okay, so let's try removing the first one. Include CPU tag. And now let's remove this one. Include CPU tag. I mean, here's the thing. Even if we remove... What if you add an at synchronize at the end? It should automatically do that, but I think this is already in there. I mean, I don't think that's gonna... Okay, so I'm actually not sure. By the way, Gory Do, thank you so much for following. Really appreciate it. Sorry I missed that a minute ago. Right, clearly there's an at synchronize in here. I wish I knew what algorithm this was following. So this is a coalesced matmul kernel. Right. Can you print what it's printing? Like at which line? What do you mean? Sorry. What do you want me to print? So you want to print what? Okay, so we've got an at synchronize in there, which is fine. Oh, I just want a better example. Okay, so let's do memcopy mpi.jl. This isn't gonna help. Yeah, I mean, they're using it the same way. They have a send request. You have multiple print statements and you don't know what it's belonging to. Yeah, well, okay, right. So we kind of do know what it's belonging to, but let's go down here. I'll delete this guy in here, and we're just gonna say, in here we're gonna say values this, and then we're gonna say histogram values or something. Okay, so now we're gonna include, and we're gonna do CPU tag histogram. Right, scroll up. Sorry. Yeah, so here we have histogram values, which indicates that we're getting to this stage of the execution before finishing this stage of the execution, which means essentially, yeah, we're getting to this stage of the execution before we're getting here, which is obviously, which is a problem, right? No at sign. Wait. Sorry, for some reason you were, no at sign for that one. No at sign for which one? At synchronize here? Okay, I actually don't fully understand how... Okay, here's what I might do. I might just go ahead and call it for now, and I might just ask someone who maybe knows a bit better. Yeah, maybe that's what I do. I maintain that you should call the different parts of your kernel manually and not with the synchronize. Right, well, the issue with that is that, you know, the kernel launches take time, right? Like, you don't want to, you know, call an unnecessary kernel launch, right? Yeah, so I was looking at the MPI call in here. Actually, I don't know what this is doing, if I'm being honest. I don't know if you can print the threads to know what start and stops. Not exactly in that order. Okay, you know what I'm gonna do? I'm gonna call it for now. BB Astronaut, thank you so much for following. Thanks for that. Oh, let me see that. This is at synchronized time elapsed function main. You know what, Cowabunga, maybe you're right. Maybe I'm an idiot here. Let me think about that. There is specifically a sync threads command that was just not in the documentation. I thought synchronize was sync threads. Look. I'm so sorry. I thought it was unified into a single command. It clearly was not. At sync threads. Oh, that's because there's no H. Sync threads was not defined. At sync. Oh, there's no and. That's exact. I'm now understanding. Like, everything is kind of like building in. Someone said there's no at sign, and I think they were talking about no at sign for the sync threads. Thank you guys so much. I'm sorry I'm an idiot. Okay, include CPU tag histogram. Give it a second. I don't know. It's going to take some time. Aborted. Okay. Well, that's a thing. Control C. All right. You're right. Well, I broke it. Okay, well, that's a thing. Also, what's this? Static shared memory. What is all this nonsense? Why is this? Oh, this is because this is CUDA. Ah, not kernel abstractions. Right. No, that's fine. I thought this was kernel abstractions code, but it's clearly not. It's clearly CUDA code. Okay. Yep. Nope. That was me just not being clear. Okay. Right. So right. Where was this written? This is written transpose shared. Who wrote this? This is Poisson Julia. Sync threads acts on a block, whereas your sync must act on the whole kernel, which local memory is not kept. 1 second, I need to think here. Yeah, maybe that is the issue. But the thing is, we don't. Okay, my only question: how do we get it off shared memory then? Right, like that's my question. How do we do that if we can't? I mean, maybe we do everything. Yeah, okay, maybe you're right. Maybe that's the issue. In which case, there isn't really a solution. There's absolutely nothing I can do without major kernel refactoring, which is what I'll do tomorrow, I guess. I'll just try to fix that one. Because there isn't really anything I can do at this stage. Because I have to get it off of shared memory, and I don't know how to do that. So the problem here is that the histogram needs to be on shared memory because it's non-coalesced writes. Major refactoring, it's like 30 lines. Right, it's going to take me like 6 hours though. But what I'm trying to say is the following. I'm going to have to... So we're writing to a bit of shared memory. And... Right, so we have each block. Okay, so a simple solution, just use less than 256 items, right? Yeah. No, I think you're right. I think that you're right that this isn't a global sync. It's a just like block specific sync, right? Which is fine. What time do you usually start streaming? It's usually like somewhere in the afternoon, Barcelona time, which is like Central European Standard Time. So yeah, and then today I streamed a bit late and I have to close a bit early because I'm making dinner tonight. But yeah, some weird American time, right? No, it's I mean it's weird in American time, yeah. It's gonna be like early mornings for you guys. Well, it's also probably weird European time as well. You're right about that. Okay, so let me think about this. Gawabunga's right here in saying that sync threads acts on a block, right? Oh, Crystal Bit, hey, how are you? Thanks for raiding with a party of 5. How are you doing? I hope you're having a great time. How's your stream? We're kind of puzzling out some CUDA stuff right now, or kernel abstraction stuff, which is CPU and GPU stuff put together. We've got about 20 more minutes in stream before I have to go for today, so just letting you guys know that. If there's somebody that you guys want us to raid at the end of the stream, feel free to let me know, and I'll totally do that. What I mean here is that no one knows the 3-letter thingies. Right, so that's why I said, like, probably like 1 o'clock Barcelona time or something like that is what I'm looking at. Okay, so this is working on, let me just write out what we're doing here. So we've got journal, new page before. I'm trying to reason about what's happening. We have shared memory resource in here. So this is going to be 128 items, right? And this is going to be our histogram that we're going to store, histogram. What we have then is a list of random numbers over here, right? So here's our list of random numbers. It's like 1, 2, 8, 7, 5, whatever. It's just a list of random numbers. And essentially what we're trying to do is we're trying to say, like, every time we have a 1, then the first value here goes up. When we have a 2, the second value here goes up, so on and so forth. So unfortunately, I don't know how to set shared memory. So 1, I don't know how to set shmem to be naturally zeros, right? So the first step is actually setting shmem to be 0. We're not doing it ideally. We're doing it in kind of a stupid way, and I know it's stupid, and I don't really know the best way to fix that, but probably the best way to fix that is with some local index, which probably means what we need to do is we need to make sure that the histogram is not larger than our thread numbers, right? So, which is not in this case. So what probably we should do is we should make this so this works over a local index instead of a global index. Yeah, that's probably fine. Yeah, no, in fact, that is definitely fine. Right, okay, we're getting there. So can I do then LID or something like that? Let's try this. So let's do LID is going to be equal to @index local, and then we're going to do linear. All right, and so down here, what we're going to do is we're going to say if LID is less than length of histogram, and we're just going to say this is equal to 0. This is our local ID. This isn't the best way to write the code, but that's what we're going to do. So then what we have to do is probably add all the shared histograms together somehow, and maybe that's the issue. So the issue could be that, yeah, okay, maybe that is the issue. Right. Okay, so then the next thing we need to do is we have to, synchronize here I think makes sense. So we have a local store of the histogram and shared memory, and now we have to write to those values. So here we're printing out all the values. Again, I'm going to remove that print statement, and then we're going to say if the thread ID is less than the length of values, it's fine. I don't think the if statement is going to matter too much, except for the case where we have over 1,000 strats or something. So this is just a quick check to make sure we're not doing anything wrong. We're going to say shared histogram of values of TID is going to be plus equals to 1. Now, here's where I'm a bit... I need to think a bit. Right. So I think this is still fine. And then at the end, we need to find some way to add all the shared memory tiles together, I think, is what the issue is. So maybe we don't set it equal to, we do plus equals here. This is really stupid, like really dumb. Let's go ahead and include... Okay, include histogram.jl, atomic plus. Yeah, yes, it needs to be atomic, you're right. How do I do that? So we're gonna set A, over here we're gonna do A is gonna be equal to this. Final histogram is equal to that. CPU histogram is equal to this. Right. Well, it's not all zeros now. It's not all zeros now. Pride Pog. Yeah, that's what I was looking for. Thapa27, Asmin, thank you so much for following. Really appreciate it. Yeah, it's wrong values, but progress, right. Okay. By the way, thanks Yawabunga and everyone else in chat for shouting at me. Again, thanks is what I'm trying to say. I know like I'm being a bit hard to deal with, but it's because I don't know exactly what the problem is. Okay, so I'm also going to remove this guy in here. Okay, so the local ID, maybe plot it now. I mean, okay, let's see what we get. Okay, so we're going to plot, oh, I have to do using plots. Yeah, who's not hard to deal with these days? I'm sorry, like, I just had a discussion earlier today about how, like, there's a right way and a wrong way to actually deal with these types of conversations. Like, when someone says that you're wrong, like, what I typically do is I think about it for a second, and then I'm like, and sometimes I don't fully understand the argument, right? And it takes me a few minutes to get there. But in this case, you're right. I think I was genuinely wrong about how the local indexing and everything here works. Okay, let's plot CPU tag histogram. And let's see what we got. Again, I've got another 15 minutes, and then I really do have to close stream for today. I'm so sorry. We're getting there, like one step at a time, but it's taken time, and I apologize for that. Okay. Right. This is... Look, every other value. So, like, one value is negative 1911. The next value is 32,564. Pause, champ. This is... I don't know. I mean, even if we're not... I mean, let's just remove this. Let's set it equal to again. And let's see what this does. Include. Then we're going to do CPU, tag histogram. Okay, so now we've got Is it not being set equal to correctly? Is that why we're... The local ID should go from 0 to 256. No. What is a local ID? What is local ID then? I thought global ID was a mix between block ID and thread ID, and I thought local was thread, but maybe I have this wrong. At index, so we have global group is the index of the work group, and local is within the work group index. So our block size is 256 right now, and our maximum and the size of our histogram is 128, right? So the size of our print out local IDs. Just screw it. Let me see what happens. Let's print out all the LIDs. At print, LID is, all right, screw it. That's what I'm going to do. LID, new line. Okay, and here we're going to include. Now we're going to run CPU tag histogram. Let's take a look at this. LID is 1234, 1234. Why is it only 4? Oh, because we're on the CPU. We're on the freaking CPU. Right. And the CPU only has 4 threads because I'm only using 4 cores. Right. By the way, what's this project about? So if you look at this fractal up here, see it's like got like a bunch of weird patterns to it. It is essentially it is an image, right? But it's also a set of equations that have created the image. One equation creates a heart. Another one creates 90-degree rotations, which is why you also see the heart here. Basically, it's a bunch of formulas put together in order to create a fractal-like pattern. What we're doing here is we're essentially manipulating those equations to create weird fractal patterns, and we want to be able to manipulate the equations in such a way that we can recreate an image. So if I feed in an image, what I want to get out is a set of equations that will recreate the image with the fractal flame algorithm. This process is known as fractal compression, and it's going to require a lot of machine learning and a bunch of stuff, but right now all we're doing is trying to speed up the time that it takes in order to create images like this, and that's what we're doing right now. Sorry, I didn't mean to sound preachy, but that's where we're at. I wanted to ask about the index, but that would sound weird. No, you're totally right to ask about the index. So we have global, and we have group, and we have local. So if this was done on the GPU, lossy, like an approximation to an image with a fractal, lossy compress it. Yeah, so a long time ago, fractal compression was a competitor with JPEG for the best lossy compression method for images, you know, but obviously JPEG won out because fractal compression just took too long. And so we're just trying to re-tackle that problem and see, hey, can we actually speed up fractal compression using modern hardware and modern computing techniques? The answer is maybe, I don't know. So that's what we're trying to figure out. That's really all there is to it. I want to make an entire video where every single frame in the video is fractal compressed, but we're going to get there. Make fractal compression great again. Yeah, kind of. Okay. Right, the local index only goes to 4, which is a problem. Yes, it's a problem, because if the local index only goes to 4, then we're in trouble. So what do I need to do in that case? In that case, what I need to do is, wait. Okay, so now I'm a bit confused as well. Reminds me of courses with Ingrid. I don't know this person. Okay, here's what I'm gonna do, guys. I gotta leave in 10 minutes. That's a hard deadline. So I'm gonna just write down a bunch of weird things that are going on that I know are going on. So first of all, the woman who created JPEG. Oh, okay, right. So in here I'm going to say, note, this is 4 for CPUs. So I think what I'm going to say here, the problem here, I think, is that the @synchronize calls are only synchronizing across let's see, blocks, while we need we need a way to combine all the shmem histograms together into a big global blob. So the issue, what I do is to replace the last line in the TID by LID and add atomic plus. Yeah, can I just... How does atomic work? Can I just do atomic in kernel abstractions? I need to figure out how to do atomic adds and stuff like that. But yeah, I'm not sure how to do that with the current syntax. But also, because LID only goes up to 4 for the CPU, this doesn't quite work the same way. So that's the other thing I'm trying to tackle with right now. So here's what I'm going to do. I'm actually going to just go in here and just say, into a big global blob. So I'm going to go down here and say this can be done. This can be done. Wait. This can be done by dd here. And I'm going to write down exactly what you just said. One, doing it, essentially making sure we use TID instead. I'm sorry, LID instead of TID for the histogram at the end. Wait. Let's just try it. This might work on the GPU, but it wouldn't work on the CPU. What if we just try it on the GPU right now? See what happens. Let's just try it on the GPU. I'm going to write this down, and then I'm going to try it on the GPU. And use atomic adds. Okay, and the next thing I need to do is figure out how to fix two LIDs. Doesn't make sense on the CPU with only 4 cores. Here for the explosion. Yeah, look, I'm going to try it. It's going to break, and we're just going to see if we can figure it out. So I'm going to go here, plus here, write this. I'm going to run this one more time. Include. Now I'm going to run CPU here. Okay, it ran. We got a bunch of zeros. Let's just try the same thing here, but we're going to do GPU. And we're going to change this to coup array of A. It's going to take a second to precompile. Oh, man. Okay, so first of all, we actually got some stuff done today. Did we write very much code? I mean, we tried to write a lot of code. We got the general skeleton of the histogram methods written down. We kind of sort of understand the theory here. We've gotten a bunch of error messages, if that helps. Oh, geez. Here's the same call to JLF apply type. Okay, I don't know where that's coming from. So I'm going to go here and just say, we're getting an error with JLF apply type. And I'm just going to say, I don't know what to do with that. For 3, fix error with JL underscore apply type for GPU. I don't know. I'm tired. Okay, we're a $$ in here. A lot was written and a lot was removed. Again, right. So that's where we're at today. So here's what I'm going to do, guys. Is it true that Julia implements array programming paradigm? Wait, what is an array programming paradigm? Okay, here's what I'm going to do. I'm going to commit this code so you guys can see it in all its buggy glory. You guys see the error messages that we have here. If you guys want to play with it, feel free to do so. But I'm going to mess with it again tomorrow afternoon. Right now, I do have to go. I have to make dinner, so I got to go. But is vector-based programming? Oh, that's fair. Is object-oriented programming, right? Imperative programming. Which OS are you using? I'm currently using Arch Linux with OpenBox. So Arch Linux, 1 second. Plus OpenBox. Okay, if you want to know the theme, feel free to go to the off-topic channel on Discord, go to the pinned messages. It's like one of these pinned messages. Let me go up here and give you guys a link. I believe that's the link. Okay. Right, so first of all, thank you guys so much for all the help today. Genuinely, thanks for all the help. I'm so sorry we didn't get anywhere, but we're getting there one step at a time. And we're just going to keep trying to get there one step at a time as we keep going. So tomorrow I'll be streaming, hopefully a bit longer than today. Today was just a 3-hour stream. Hopefully tomorrow will be, 5 hours, something like this. And we're just going to try to knock this out tomorrow and get not only this histogram method, but another histogram method implemented. And then we're going to start to work on other methods. I'm really interested in this histogram problem because it's just, I don't know, it's one of those things, like when you start tackling a problem, it becomes interesting. And like, I said before that I'm not interested in a lot of the physics applications, blah, blah, blah. And that's true. But, yeah, let me see what this is. Yeah. Let me see. Okay. So, let's go here, paste this. You can definitely, static arrays are super handy in kernels. Yeah. So definitely, so S vector is another thing. So S vectors, do we want to use S vectors? Let me write that down also in the notes, because S vectors are particularly useful for CPU stuff. So let me yank this, paste this down here, and I'm going to write this down. Think about S vectors. And let's just, yeah, I mean, obviously, I know a lot about them. So this is good. Thank you so much for bringing that up. Otherwise, I would have forgotten. Okay, good. So I'm going to commit this code, and then we'll call it for today. So let's do git add histograms.jl, git commit -m, adding buggy kernels. Sorry about that. Face. Perfect. Git push. Origin master. Oh, man. It's on the Simuleos directory if you're interested. Okay, so that's it for now. Seriously, guys, thank you so much for coming in. Let me see who's live and who we want to raid. What I might do, guys, because there aren't too many people live right now, I might just do a raid on Kitboga, just because I like Kitboga's content, and we don't have too many people here to go on with the raid, so I'll go ahead and start that. Raid Kitboga. Look, I know so many people watch Kitboga. I know it's kind of sad to raid someone like that, but also, like, I really got to go. I don't have time to, like, hang out and chat after this is done. So, thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos, where we knock this bug out of the park. Where we attempt to knock this bug out of the park. Okay, thanks again, guys, and I'll see you next time. Bye, guys.